Hello, everyone, and welcome to the .NET Conf Student Zone. I'm here with Scott Hanselman. Hi, Scott.
Hi, how are you?
I'm doing great. I'm Katie, a product manager at Microsoft with .NET, and we're really excited to welcome you to this event. This is a pre-conf event for the overall .NET Conf. Scott, do you want to tell us a bit about .NET Conf?
Yeah, so this is great. We are at the beginning. You're at the very beginning of a multi-day celebration with our friends in the community. We're going to talk about .NET. We're going to learn a ton. It's all free. It's all virtual, and it's all recorded. So you may be watching this live. You may be watching it recorded. You can watch it later. You can watch it at your leisure. This is going to be fantastic. And the pre-day here is just for beginners, just for students, just for folks that are getting started. So we're going to set you up for success for the stuff you're going to see tomorrow and the next day, right?
Exactly. And we're streaming here to folks all around the world. So we'd like to welcome you from wherever you're tuning in. And we're really excited. We're going to be building a .NET portfolio. And like Scott said, it's totally for beginners. So we're excited to show you around. I have some slides. Let me pull those up. Awesome. So once again, welcome. We have a great lineup of speakers for you today. And each one of these speakers is going to be showing you how to use a different .NET product and build an awesome project. So Bethany is going to be showing you how to create your GitHub profile. We have some sessions on IoT, ML.NET, Blazor, everything you need to have a super well-rounded portfolio.
Yeah, having a portfolio is super important for folks that are just getting started. It's a great opportunity to build up your skill set and also your online presence. And what they're going to be talking about and what Bethany's going to start with is that README, that homepage for yourself. When someone visits your page, whether they be one of your peers or whether they be a recruiter or a teacher, they're going to see the cool stuff you're working on, and you're going to have full control over what that looks like. So that's going to be a great session.
Exactly. So let me give us a little run through of our day today. So like we said, we're going to start you out with, teaching you how to create your GitHub profile. Then we're going to jump right in and show you how to create a project portfolio website with .NET, and that'll be using Blazor. Scott, do you want to give us a little background on Blazor?
Yeah, Blazor is really, really interesting. So a lot of people know about .NET or they've heard about C# and .NET, and you'll see for the next couple of days how you can build anything. But Blazor is really cool because it's a way for you to write websites with C# without having to learn JavaScript. So you don't have to learn multiple things. And the Blazor technology lets you put together a great looking project portfolio site. And if you like, go and host it on Azure or somewhere on the web and share it with your friends and your family and your coworkers. Blazor, that technology allows you to run .NET in the browser using a thing called WebAssembly that I'm sure they'll talk about in that session at more depth. Super cool technology.
Exactly. And then from there, once you're set up with your profile, we're going to be running you through this longer project. So what we're going to be doing is showing you how to track your water consumption. So that'll include some awesome IoT, some ML.NET to estimate your future water consumption. We're going to build a backend for a water consumption tracking website, show you how to make a mobile app. Then at the end of the day, Diego's going to show you how to ace your next assignment with some awesome testing in Visual Studio.
And what's neat about this idea and this project is here that IoT, that Internet of Things, is going to be connected to some backend that'll do some machine learning and do some analysis on that. But we're going to be tracking water consumption. You can track whatever makes you happy. You can track blood sugar. You can track carbohydrates. You can track anything that can be tracked. So even though we're going to be building an end-to-end water consumption site, it's an anything tracking site. And it's going to give you an opportunity to maybe change that, make it your own. And again, post that code on your GitHub, which you can then feature, as Bethany will show us, on your GitHub profile.
Exactly. We really want you to take this content and make it your own. So whatever interests you, we hope that you can kind of adapt what we teach you today so that you can really showcase yourself through these projects. So for all of this content, we're going to be working out of our GitHub repository. So let's go check that out right now and see what that looks like.
Yep, right here in GitHub, you can see that I've got the .NET Conf student zone. That student zone is a public repository, which means that all of that code and all of that information is not only public, but available to you and constantly being updated. We can see Justin was just in here. So go ahead and check this out. Check out the table of contents, all the different links that you need, as well as the resources that you're going to want and opportunities to link to other sessions and register. Of course, you're going to want to come down here. You've got the agenda, each of those sessions, and then the repo itself can be run in multiple ways. The repository can be run in multiple ways. Even if you don't have a fast computer, you can go and use GitHub code spaces and connect to it, which is going to be really, really cool. So no matter what kind of machine you have, we're going to set you up for success with these learning resources on the repository up here at .NET Conf-Student Zone.
Exactly. And beyond this session, whether you're watching it live with us or after the fact, this repository is going to live on. So you can always check back in here and look at some of that solution code as well. If you're going through a session and you want to see what that looks like, we have all of that inside of this one repository.
Very cool.
Awesome. Let's take it back to the slides. Great. The other thing I really want to emphasize here is that we have a challenge, a cloud skills challenge, so that you can get ramped up with .NET beyond these sessions and even win some swag potentially. So the registration link is here. We'll drop that in the chat as well. And with this, we really just want to thoroughly show you how to use .NET and C# and get you ramped up.
Yeah, it's really going to be cool. I know it can be overwhelming, but I want you all of our friends who are watching and anyone who enters into the student zone to know that we want you to win. We want you to be successful, and we're going to give you as many resources as we possibly can. If you're finding that you can't find something, go ahead and put an issue. Go ahead and raise an issue in that repository, and folks from Microsoft and the community are going to be in there watching for your questions if you get confused, and we can go and maybe add an additional link or point to a Learn module that might answer the question. So we are here, we are real people, and we want you to be happy and successful and enjoy a really great .NET Conf.
Exactly. So like Scott kind of alluded to, we really want to be here for you, and .NET is open source, so we really encourage you to check out all of our work in our overall repositories. And I think the next thing we should really do is talk about what is .NET, because I know a lot of folks who are tuning in may not actually know what .NET and C# and all these things are. So as you can see on the screen, .NET is an open source developer platform for building different types of apps anywhere. So Scott, I know you've been using .NET for a while now, so I would love to hear from you, more about this. What really is .NET?
So .NET, the name .NET, is a platform, and platform is a kind of a weird tech word that we hear a lot, but we don't really know what it means. Why is it called a platform? Well, it's called a platform because you stand on it. You build on platforms, and platforms are functions and APIs, application programming interfaces. They're things that you can use. It's a toolkit, a developer toolkit for building all your apps. So anytime you hear that word platform, you're going to want to think that that's a toolkit. for building your apps. And what's cool about .NET is you can build apps for any device. You can build apps for the web. You can do Android. You can do iOS. You can write Mac apps. You can write Windows apps, which means that you can learn a language like C#. And now, with that information that you've learned, you can build a web app or a mobile app, or you can do microservices. You maybe heard the word Kubernetes. You can do Kubernetes with C#. And then a lot of your favorite games are actually written in C#. So you can write games. And then Katie alluded to this idea of the Internet of Things. I've got these devices on my desk, little tiny chips. These actually can be written in C#, and you can write code to talk to devices, or even a Raspberry Pi, which you might have or have at school, can be written to using .NET. You can learn all about that stuff up at the .NET website. We've got links again to all of this stuff out there. And you can download .NET and get started really, really quickly. Or if you don't want to download anything, you can actually walk through our tutorials online and do Hello World. And we've got videos with our friends as well on YouTube to allow you to do the first installation and first running of a, Hello World, which is a great way to get started with .NET.
Yeah, and while we're here, we actually do have some more learning resources on this site. Scott, if you want to take us to the Learn tab, we can kind of show where you can go if something comes up in one of these sessions and you want to learn more about it. We have a whole host of resources for you.
We sure do. We've got a whole section on Learn to Code C# with a ton of beginner videos, playlists on all kinds of stuff. We can go deeper into things like architectural guides, but the Learn to Code section right off of that Learn tab gets you into this toolkit, and you can go and learn at your own pace. We've got interactive online lessons, we've got notebooks, and a ton of videos with our friends featured to teach you everything from web APIs to what is ASP.NET and how do you make websites using C#.
Yeah, I see a familiar face in those first two videos.
I may have popped in there once or twice, and I think you'll be in there soon as well.
I'm sure I will. So going back to our slides, I also want to talk a little bit about C#. I've heard some people are like, well, what is C# compared to .NET? Scott, do you want to give us a good explanation there?
So if .NET is the platform, it's that surface that we build on top of, I can talk to that platform, that .NET platform, using C#, which is a language a lot like C or C++ or Java, or I can use F#, which is a functional language that you might hear in the context of things like Haskell or OCaml, if you've heard any of those words. And then Visual Basic is a great beginner language that you can move to from other versions of Visual Basic. They all sit on top of that .NET platform. C# is kind of one of the most popular languages. It's one of the top 5 programming languages on GitHub. So it's kind of first among equals in that list of languages. So C# uses the .NET platform and stands on it to build all of the different things. It's the platform that makes it possible, and C# is the language that we use to write our code.
Yeah, and we talked about this a bit earlier, but I just want to show all the things that you can build with .NET. And I know, Scott, you have some awesome projects in some of these different areas, especially with IoT and mobile. And I know you have your website as well.
Oh, yeah, that's a great point. So I've got my own websites that run on .NET. I've got Android phones like this 2-screen Surface Duo that runs .NET. I just downloaded a couple of Xbox games earlier that are written in .NET and written in C#. IoT devices like those little ones that I pointed out, as well as Raspberry Pis and different devices like that. This is actually a Pi top. This comes with .NET and C# and is a Raspberry Pi inside. So anywhere from tiny devices to massive cloud applications. In fact, a lot of you might use Stack Overflow to answer questions. People don't realize that Stack Overflow itself is written in .NET. So you're using .NET every day when you go to the Xbox, when you go to your Bing, or you go to Stack Overflow. C# is there, and .NET is there behind the scenes making it happen.
Yeah, and that's a question I get all the time. Like, who is using C# and .NET, and what can I build, and where can I see examples? And the examples are all around us. As Scott said, Stack Overflow, Chipotle. So there's a whole host of different companies using .NET to build.
I think really you had me at Chipotle. It's the Chipotle for me. So at that point, good night, everybody. Chipotle uses .NET, and you should too. That's really all you need to say.
Exactly. That's the thing.
Yeah, and we actually have a session. This is what's great about the Student Zone. You're going to learn about these things so you're ready for .NET Conf. We're going to see Roberta from Stack Overflow come and talk about how they use .NET and C# over there. So you may hear from some of these companies as well during the next couple of days.
Oh, that's awesome. I got to tune into that one for sure. I want to hear that whole story. So it looks like it might be time to kick it over to Bethany, but first let me talk about a couple of the resources that you can reference throughout the event or following it. So we have go check out and sign up for your Student Azure subscription at this link here. We'll put all of these in the chat, don't worry. The Cloud Skills Challenge that Scott and I talked about earlier, our GitHub repository. Remember that all of the code that you're going to need for these sessions is in that repository. And we have a couple links to learn more.
Yeah, it's going to be very cool. And in Bethany's session, she's going to talk about setting up your GitHub profile. I've used some of Bethany's tips and set up my own GitHub profile. Just as an example, we can switch over to my screen and you can see I've got my personal links and the different things that I care about. Hopefully your GitHub profile will look cool like this as well. And Bethany's going to teach us how in just a few minutes.
Awesome. All right, let's kick it over to Bethany.
Hi everyone, thank you so much for joining me for my session today. I am Bethany Jepchumba, a cloud advocate here at Microsoft. I work with students and educators, giving them information on data, AI, and machine learning, as well as learning from them. So today I'll be talking about up and running with GitHub, giving you an idea of how you can get started with GitHub, some few terminologies that you need to know, as well as creating your own README. So let's get started. As I've mentioned, I'll be talking about up and running with GitHub. So I'm hoping by the end of the day, you'll be as good as the octocat there, being able to fly with the knowledge that you get. The main thing that you might need before, as you continue the session, is number one, create your GitHub account. We'll go ahead and create our GitHub account at some point, so you don't have to do that now. And then the other thing you'll need is to download Git and Visual Studio Code. I'll also show you how to use Visual Studio Code on the browser, but for now, if you're able to download both Git and Visual Studio Code, that would be great. Okay, so what are we covering for today's session? The first thing is understanding what exactly is GitHub and why we really need GitHub. The second thing is understanding the difference between Git and GitHub. Are they the same thing? Are they not? We'll find out. Thirdly, we'll learn about how you can collaborate with others on GitHub. And finally, creating your README on GitHub. Okay, so the first thing, as I mentioned, is understanding what exactly is GitHub. GitHub is a web-based platform where you just host your code. So it's a platform that enables you and millions of others in the world to host their code. You host it free of charge, but in case you need other extra services, you will pay for them. But as a student, I'm sure you get a lot of free services on GitHub. Why exactly do we need to host our code on GitHub? Number one is for collaboration, because when you're in your local machine, I may not be able to access your code unless you share it with me. So imagine we're sharing our code with OneDrive and you're working with thousands of people. How do you go about that? Will everyone have the same version of the code at the end of the day? I don't think so. So GitHub helps you collaborate and share your work with others. Other than sharing your work when collaborating, the other thing that GitHub helps you with is also sharing your work with recruiters and also with assignments with your lecturers and so on. So it's very important if you want to share your work, it's very easy when you're using GitHub. The other one is contributing to open source. We've just finished October this last month, and one of the big things in October is the Oktoberfest. And this gives you a platform to contribute to open source and so on. And the main platform you do this is through GitHub. And lastly is version control. And I know you're wondering what exactly is version control, because for me, when I had it the first time, I was like, why do I need to control my versions? Version control comes in when everyone is working separately on their code. So you realize there's someone from the other side of the world probably working on one feature, another person from another side of the world working on a different feature. How do you come together and be able to tell who worked on what part of the project or who worked on what part of the code? So version control helps you to track the different changes you make over time, and you can be able to see if anything goes wrong. You can be able to go back and check what happened at this time, what happened at this time. And you can see the octocat in the image. You can see there's a negative, an additional, a negative, and an additional. So you'll find yourself probably removing some code or adding additional code and so on. So that will help you, GitHub will help you in tracking your changes over the period of time. I mentioned earlier Git and GitHub are not the same thing. So what exactly is Git and why is it not the same as GitHub? Before I go into the difference between Git and GitHub, I want to give you a scenario. If I tell you a car and a carpet, are they the same thing? Because a car is a device, a vehicle that moves you from point A to B. A carpet is something that does not move at all. So same with Java and JavaScript. These are two very different languages with two different syntax and so on. So it's the same thing when it comes to Git and GitHub. I mentioned GitHub is a web-based platform that helps you store your code. Git is now where you are able to keep your local software and save the project snapshot locally. And then you are able to send it to GitHub. The first thing I want to talk about is you storing your project using GitHub and Git. And that's how you do this is through a Git repository. So for example, you have different files and folders creating a program. How do you bring all this together? The main thing is using a Git repository. Before we get to creating a repository, let's go to GitHub. And this is how the GitHub homepage looks like. So github.com, you'll be able to see, this is essentially what you'll be able to see. The first thing you can do is sign in or sign up, depending on whether you have an account or not. As I already have an account, we'll just go ahead and sign in. And then with two-factor authentication, I'll have to input to verify. And once verified, I can access my GitHub. So you can see from my homepage, you can see different things here. But the main thing we want to do is to create a new project. And by creating a new project, we are creating a new repository. So I'll come to my profile picture here and select create a new repository. So let's wait for it to load. As it loads, the other thing you should be doing is ensure you download Git. So using the link I shared earlier, go ahead and download Git. Download either for your device, whether it's Mac, Windows, or Linux. And then the other thing we'll be using today is Visual Studio Code. So ensure you also download Visual Studio Code. Okay, let's go back to GitHub. It's already loaded, and I want to create a new repository. So I'll come here to the create new and then new repository. Here it will ask me to give some details. For example, the name of the repository as well as who exactly owns the repository. So the owner, I'll select myself, and then the name, I'll name it .NET Student Conference. Since this is a unique name to me, it will be okay since it can be, I've not used this name before. The other thing I can do is give a description. So this is a demo for .NET Conference. And then choose whether I want my repository to be public or private. For now, I'll have it private. The other thing you can do is add a README. A README will give people an idea of what exactly your project contains. So a README will help you say, okay, I'm building a demo for .NET, this is how you implement the demo and so on. I don't need that at the moment. And then there's other things you can do, such as creating a git ignore, which will now, in case there are files, for example, that have your secrets or your different keys, this is where you'll put the files so that it does not upload to GitHub. And in case you're using an open source, probably it will ask you which license do you want to use and so on. Once you're done with that, you can go ahead and create the repository. So as it is creating, the next thing you need is how we've already created a repository. So the other thing is, how do you use it locally? Like, how do you either download it to your machine, or how do you create a repository locally? So I'll go back here, and as you can see, I have a link, and it's telling me I can either create a new file or upload an existing file and so on. And it's also giving me ideas of how exactly I can probably initialize a file locally and so on. So for now, what I can tell you to do is probably have your file local. So I'll go to your studio code, go to my terminal, create a new terminal, and then I'll git clone. Git clone will now help me have the repository locally. So it's cloning to Pikachu. Once it's done, it's telling me the repository is empty. So probably CD will help me go into the repository. The name is .net. And then I can open the code inside the repository. So it will give me a new window with the folder. The first thing I can do is probably create a new file, and I want to create a README, right? A README will help me tell people what the repository is about. So probably I'll need to edit it since it's markdown readme.md. Sorry. Rename, then readme.markdown. And then I can tell people, hey, this repository is for .NET conference. And this is the first session. And we are learning all about Git and GitHub. So I've created a new file locally. So how do I send it back to my GitHub file so that I can be able to share it out? So there are two ways. First, this is the simplest way. You would just write a commit message here and send it, publish it to a new branch or to your main branch online. The other way is going back to the terminal. And the first command you'll do is git add. Git add will add the file that you just created and stage it. So an example I can use for this is, for example, you're going to a bookstore. The bookstore is probably the stage. When you go there and you buy a book, that's you committing yourself to buying a book. When you read it, that's now entering into your brain, and you're able to use the knowledge to do different things, right? It's the same thing. So probably this is a bookstore you're going, and the first thing is adding the book to your cart. Once you've added the book to your cart, you do git commit. With git commit, you have to include a message. This message will tell people what exactly your commit is about. So I'll write add readme, because I've just added a readme, and you can see it's one change and 3 different insertions that I've done. Once you're done with that, you can go ahead and push your code online. So git push. It will probably request you to add your username and your email, so ensure you do that. I've already signed in with my GitHub email here, so I do not need to do the same thing. But for you, if it asks you that, just ensure you update your username and email. Once done, I come back to the browser and refresh, and you can see the new file is here. .NET Conference, first session, and we're learning all about Git and GitHub. So that's basically what you need to do when you're working with you've just created a Git repository online and you want to work with it offline. The other way you can do this is creating a Git repository offline. With that, you need to use a command git init. I won't go through the whole process again because once you git init, it will transform a folder into a repository. And once it's transformed into a repository, you can add your files and then repeat the commands that I've just done here today. The other thing I want to talk about is branches. So let's say you're collaborating with other people, right? And you want to share you want to work on a feature that you don't want to be published immediately. That's where branches come in. So for example, you have a website you're working on and there's a new blog you want to write, but you don't want it to publish immediately. So you'll need to create a branch, and that branch will now be able to, with that branch, you'll be able to now work with it without making any changes to the main repository or what's hosted. And once done, you can be able to merge the branches afterwards. So the first thing is creating a branch. So I'll go to Git branch. And it's telling me there's one branch, which is main. So I'll do git checkout and then probably Bethany. Oh, wait, I'll have to create the branch first. So git branch, and then give it the name Bethany, and then git checkout. So now I'm working on a branch called Bethany. So probably in Bethany, I want to add a new file. So come back here to my files, and then probably index.html. I don't want to add much here, so I'll just probably just add some simple code in HTML. So let's see, what exactly do I want to add? So HTML, and then probably title will be my name, Bethany, and then inside I'll just publish probably a heading h1 and say this is Bethany's new file. And that's it. So if I come here and then do the same thing, git add, git commit, and probably I'll just say created a new HTML file for Bethany, and then git push. So I'll have to, you see it's telling me the branch does not have like a remote or upstream to go to. When I cloned here, it came from the GitHub back to Git. But then if I'm going all the way back to Git without having the direction that I'm headed to, it will tell me I need to set the upstream. So I'll come back here and then do the same thing, git push, set upstream origin, and then once done, it will be able to now push a new branch. And if I come back to my repository and refresh, you'll see I'll have two branches here. So I have main and I also have Bethany. Okay, so the next thing we're going to work with is now how do we've already tracked changes. We've already learned how we can be able to add, commit, and push our code. But then how do we now merge from branch A to branch B? So we'll go back to GitHub, and then it's already giving me an idea of what I want to do. So just compare and do a PR. That is, do a pull request. So that's what I'll do. I'll compare the two branches and then merge them together if they can be able to be merged. So created a new file, checking mergeability. it's able to merge. I can leave a comment, probably in case you're working with other people and you need them to understand what you've done better. You can leave a comment and then create a pull request. Okay, so we've been able to do a merge, we've been able to do a push, do a commit. The last thing probably I'll want to talk about in terms of collaboration is doing a fork. So you've seen I've been able to send all my code here. I've been able to work on my own in isolation, and I've been able to create a different branch on my own. But then what if you're working on a bigger project? So you'll probably need to fork a repository. This is where fork is. Of course, I'm not sure I can be able to fork my own repository because it's my own. So I'll go back to GitHub and look for, I'll go back to GitHub and probably look for one of the trending repositories. So there's a Microsoft repository that's trending here. It's common packages for MakeCode. So I can be able to select that repository. And then once done, I'll then be able to see if there's any issues I want to work on. If there's something interesting I want to work on, I can go ahead, fork the repository, work on it locally the same way you've been working on your branch. Then once done, you can go back again and do a pull request. So it's taking a while to load. So let's give it a minute. Okay, one more second and it's loading. So this is common packages for Microsoft MakeCode editors. And you can see there are a few pull requests. There's no issues here. So probably what I'll want to do is just to fork the repository and then make it my own and see if there's anything I'll need to change. Once I've been able to change different things I want to change, I can go back and do the same thing I did, do a pull request, merge it. So technically, I won't be able to merge it completely because the repository is not mine. So you'll see the listed pull request here, and you can be able to merge it. Okay, so the last bit of the presentation, I've talked about pull requests, forks, and merging. So I'll leave you with one assignment. Go and look into GitHub discussions, understand how you can build a community on GitHub. So that's an assignment for you. The last bit is us creating our README. So before we conclude, we need to have a README. So a README, as I mentioned earlier, tells you information of what is contained in a repository or in a file, the different files in a repository, what are the contents, and so on. The good thing with GitHub is you can also create a README of yourself. So this means you are telling people essentially who you are, what you're doing, and so on. And it's very easy to create a README for yourself. You go ahead and create a new repository. And the repository will have the same name as your username. So my username is Bethany Jep. So my repository will also be Bethany Jep. Add a README, and then you can either have it public or private, depending on what you want to do. So I'll leave mine as public and then create the repository. It is essential for you to add a README there because the README will now determine what are the contents of your profile. So if I come and edit, see it's telling me Bethany Jep is a special repository because the README will appear on my GitHub profile. And these are like some of the ideas I can get started with. So I can just, this whole part is commented out, so it won't be seen. So probably I might want to say, I might want to use this point and say I'm currently working on 30 days of data science And then what am I currently learning? So I can say I'm currently learning machine learning, Azure, machine learning, and then probably what am I looking to collaborate on? Ask me about. So I can say ask me about data, machine learning, and AI. And then the last part is how to reach me. So how to reach me, I can either add links to my different profiles. So for example, if it is Twitter, I can do something like a link to my Twitter profile, which is Twitter https twitter.com/Bethany Jep. Or since I use the same username everywhere, or find me at Bethany Jep everywhere. And then once done, I can go down here, commit my changes. You can see it's already telling me this is update with me. Then you can add an optional extended message. So this is the message that I've written. So hi, I'm currently working on 30 days of data science, learning Azure machine learning, and you can find me on Twitter or Bethany Jeff everywhere. So if I go to my profile, you'll be able to see the same thing replicated there. So today, after you're done working on the projects, you can come here to your README and copy a link of the project of what you want to showcase. You can add even a picture here. You can add different widgets and so on, and share with people, hey, I've been building a project on .NET, and here it is. And I think that's about it. That's about what we're supposed to cover in this session. So thank you so much for joining. The main thing I need to remind you of is that you can find all the resources you need to get started with all we've talked about today with GitHub Student Pack, learn about certifications at aka.ms/learnstudent. The other thing is we are creating a cloud skills challenge. So in case you need to go back and sharpen your skills, you can do so using the cloud skills challenge, aka.ms/.net student CSC. And lastly, all the contents of today's sessions will be in the GitHub repo. So ensure you also visit our GitHub repository for all the details you might need. Thank you so much for joining me today, and I hope you've learned a lot about GitHub. Can't wait to see where you go from here and how you're able to utilize the knowledge to interest recruiters into your profile. Thank you so much and have a good rest of your day.
Thank you, Bethany. That was amazing. Next up, we're going to be teaching you how to create your live resume website, all with .NET. And in particular, we're going to be using Blazor, a tool that lets you use C# on the web. Vincent had to step out, but our good friend Matt Soucoup is going to be taking over to help run you through this session. So Matt, go ahead and take it away.
Hey everybody, welcome back to .NET Conf, the Student Zone. Super excited. We saw how to build a GitHub repository and everything. And in this session, we're going to build a Blazor app to show off your resume with everything that you learned in the Student Zone for .NET Conf 2022. My name is Matt Soucoup, and as I mentioned, we're building a great Blazor application to show off your resume with everything that you learned. So this is the second session in a day long of learning, and you're going to build a water consumption app in the sessions that go after this. But let's take a look at how you're going to use Blazor to build a resume application to show off all your skills. So what we're going to do here in this session is that we're going to build a Blazor app on the front end. So the Blazor app is going to be like our web app, and it's going to run, well, in a browser. And then we're going to define some JSON more or less as like our database that's going to hold all your skills in it. And then third, we're going to integrate them together so our Blazor app can show all the skills that you have for your .NET, for your HTML, for your C# in the app, in your resume for the world to see. Blazor, JSON, integrate them together, perfect resume, and ready to go. So that's what we're going to do today. All right, so when we build a Blazor app, we're going to want to think in components. And so what a component does, it really like breaks things down, and it's going to do one thing, and it's going to do it super duper well. And so a component could do, it could just be showing off presentation. So it's just like showing off data. Or a component can also be what I'm going to call smart and handle like events. It could handle other components. So components can be nestled within other components, and it could process data. It could process events and things like that. So think about your resume overall. You're going to have things like an about section. You might have things like an education or experiences or skills. So when you break that down and want to make sure a component does one thing and does it well, you're going to have just like a skills section component. All it does is take care of displaying skills. But you're going to have maybe a resume component as well. And that component takes care of grabbing all of your resume data from wherever it is. In this case, it'll happen to be a JSON file, takes care of grabbing it and gives that skills component just the information that it needs to display. And you'll have something for the experiences and something for the education as well. So you have data components or presentation components that just display data, and you have these smart components that hold other components and then grab data, hold events, all that other goodness, lots of component stuff. So let's talk about them just a little bit more. So the way these components are architected is that you have data that, what I'll say, flows down or flows into the component. And when you get the data that flows into the component, that data, the component then uses to display. So for a skill, it's going to display like, I know HTML and I know C# and I know CSS. So that data comes down into the component. But a lot of times, you're going to have the component, you do something to it. Like maybe you hit a button, or maybe this skill's added, or something like that, where the user takes some interaction with that component. And so the component's going to say, all right, something happened to me and I want to let the world know about it. So events flow up or flow out of it. So data comes into the component and then events go out of the component. And so that's kind of like the architectural principles that we'll learn about today and that we'll handle. All right, so that's the architect. We learned about components. We learned about how data comes in. We learned about how events go out. So let's take a quick peek about how we will actually go about creating a Blazor app. And we're going to use something called the .NET CLI, or the command line interface. And so we would sit down at a terminal, and then we would type out .NET new, Blazor WASM, and Blazor WASM means Blazor Web Assembly. So we do .NET new, Blazor WASM -O for output, and then give it a name for the directory that we want our files created in. And then over here, you can see the screenshot of where we have various different things. And this is the template that gets created. So we would have a pages template, for example, a folder where our various different pages get put into. We'd also have shared, where various different shared files get put into, and these, whatever's in there would be able to be used across the entire application. And then you also have a www root directory as well. And things that go in there would be like your CSS files that are going to be used for basic HTML type things. And so these are more static type files, where things that go in pages or in the shared are going to be processed by the Blazor engine to create dynamic information that'll be rendered. Whereas things in the www root are going to be like CSS and JavaScript and stuff like that, that's static, that the Blazor engine doesn't really have to worry about actually doing anything with. This will become more apparent as we get into further on in the demos. All right, so we've talked about all those components before, but let's take a look at how one actually appears. So when we do that .NET new Blazor WASM app, we're going to get a bunch of different these components created up in the pages directory. And this happens to be one of them. We're going to get something called counter. Now, the first thing I want to call out here is how you have the @page/counter. So what this is doing, it's telling the Blazor engine that, you know what, I'm a counter, but really I want to be a page too. I want to be able to have somebody be able to navigate to me. And so I have this app called myawesomeresume.com. So if I do myawesomeresume.com/counter, this component then is going to be rendered. Now notice all these @ symbols. We have @page. Then further on down, we have @current_count. Then we have @code. This is how data not only gets rendered, but also how we let Blazor know that things are actually code to be run. So you can see that we also have like the H1 for the counter, a heading. And we have here paragraph, and then it says current count. Then we have the @ symbol and current count. So we're mixing in HTML with actual C# code here, or what's called Razor markup. And so @current count in the paragraph, the first purple box, is references down to the current count in the @code towards the bottom. So I know this is kind of back and forth. So what that is, the private int current code, that's a variable integer that's set up. And then in the paragraph above, whenever current code changes, current count will update as well. All right. I know I was saying current code before, but I meant current count everywhere. All right. So then how do I change it? Well, I have a button on the page again. Now this button, again, HTML. But over in highlighted, I have a onClick event. And you notice it has the @ symbol on it. So it's telling the Blazor engine, you know what? This is going to be some C# code coming at it. It's going to be dynamic. We're going to do something. And this happens to be an event. So something's going to actually flow out of this here and interact. It's going to say, hey, you know what? I have the user doing something to me. Pay attention. And where it pays attention to it is the increment count event handler, which is defined down in the code section below. And it just says, you know what? Increment the code variable ++. Current count ++. I keep on saying code. Current count ++. Increment that. And then up above in the paragraph, it'll just pop it up. Keep on going. So you can really just hammer on that button class, button primary. Keep on hammering on that button. And the text will keep on going up and up and up because that event handler will just be getting called over and over and over. All right. So here is the application that we are going to create today. It is nothing but components all together. So what we're going to have down the left-hand side is a navigation hierarchy, a navigation menu. What it's going to be is going to say, you know what? We're going to have a home page. Then we're going to have something else that says resume. Then we'll put that click in there. We'll have one that says click. We'll have one that says like fetch data. We'll have a bunch of stuff in there, but that's how people will navigate around our application. And whenever they hit something in there, it'll change what's on the right-hand side. So when we say resume, when they click on resume, what we'll have show up on the right-hand side are several components. One for the about section, which says, you know what, I'm Matt and I'm really awesome. We'll have another one for experiences, which show every single experience that I have. Another one for education, which shows where I went to school. And then finally, we'll show one with skills. So each one of those boxes represent a component from my resume. And overall, we'll also have a component that controls everything. And we're going to call it a resume that you don't see here, but you can think of about experiences, educations, and skills being composed or being surrounded by another component called resume. So that's what our application is going to look like, our resume application. Navigation, where we can move things around within the overall app, And then for the resume component, it's going to have about, experiences, education, and skills within it. All right, and so here's how we actually navigate around within it. You'll see that we're going to be using a nav menu.razor class over on the shared folder, which you can see over on the left-hand side. So because it's in that shared folder, all components have access to it. So nav menu.razor, and then the code for it over on the right-hand side, we have nav link. And what nav link does, it highlights in the UI when you're actually looking at it, when the component's there, it's highlighted. When it's not being displayed, it's not highlighted. So that's what nav link does. It's like a helper class for you. And then we say href equals resume. And so if you remember way back when we were looking at the component for the click or the counter, when we said page equals /counter, that's how we would get to it. So if we were going to be looking at the counter nav, we would say href equals counter. So in this case, we're going to do href equals resume. And then right below where the span is, we're giving it some font images. So here we'll be giving it a plus. And then we're saying resume to it. So the important part here is navlink, href equals resume. So that tells the Blazor engine which component to navigate to. And then we're just saying, you know what? Display resume next to it. All right, and here's what our resume component is going to start out looking like. Notice the at page up above. So we're saying, you know what? This is whack resume. So myawesomeresumesite.com/resume brings up this component. It's a page. Hey, I'm a page. I want to be displayed. Then way at the bottom, we have the code section. So we're giving a variable called name, and we're assigning it Matt. And then I'm getting at that variable underneath the page title. I'm just saying at name, so the page title is just going to be Matt. And then I just have some HTML code inside of it where I have a div class of about, and it just says about within a header. So that's what the initial resume component is going to look like. Now, let's talk about that second part of the talk way back in the agenda, what we're going to be talking about, the data that we're going to display. And that's our resume data. It's going to come in with JSON. And what's nice about putting it in JSON rather than pulling it out of the database is that we can go in and change it, and then our website updates too on the next refresh because it's going to be pulling it out of the file right away. We don't have to worry about updating the database. It's just there within our hierarchy. Now, if you look at where it is, it's in the www root. So it can easily be able to get at. It's not in the dynamic portion like the shared or the pages portion of the Blazor site. And the way it looks is just we have an about section, and then we have, which is just a string, and then we have an experiences section, which happens to be an array. And then we have an experience object within it, which has company name, title, tenure, and description all put in within it. And then further down, we would have an educations array and then a skills array. And each of those would have objects within those. So then we have to translate that JSON over to C# somehow. And the way we would do that is actually create a bunch of C# classes that have nothing but properties in them. And those properties, then when we pull them out, pull them down from the web, and I'll show you how to do this, we can automatically say, you know what, .NET, we know what this JSON is going to look like. It has these properties in it. Go ahead and do this mapping for us. All we have to do is give the .NET runtime the properties, and it's going to populate all the, give them these classes. It's going to automatically populate all the properties for us. So we have an experience one with the company name, tenure, description, and title. Same thing that we looked over on the JSON. As long as we match up the property names, it's going to take care of populating them. Same thing with education, same thing with skills. And what's cool if you look at resume model, we have the about section there, but then we have lists for experiences, we have lists for educations, we have lists for skills. And what a list is, it's pretty much a fancy array. And what's fancy about it is that the brackets experience model, it tells .NET, say, you know what? Only experience models can go into this array of objects. We can't put anything else in there. It gives us a bunch of other functionality, but that's a really nice part of it, is that only experience models can go into this experience list. Same thing for the education, same thing for the skills. So it's strongly typing our variables for us. So that's how we're going to get the data out, how we're going to model it. And then finally, how are we going to fetch the data? So there's a couple different cool things that are going on here. First off, what I want to note is, again, we're using the at page concept. And the second thing is that we're using at type, or at using types. So what's that? I'm going to go back to the page before. You'll see that we're using namespace types on the second line. And so what namespace types does, it's like a folder way of organizing our classes. So it's entirely possible that another class, like say in a .NET framework somewhere, or could have a resume model class in it. Probably not, but it could. Or another library that we're using could have resume model or experience model, or we could have name collisions. The namespace is like a folder hierarchy, so we wouldn't have that. So by calling it types, our class name, our full class names really are types.resume model or types.experience model. So that's what namespaces do. Here, when we say using types, it's like a shortcut. We're going to say, you know what? I know that everything that I call resume model down below, I know it's going to be in that types namespace. So don't worry about it. It's cool. I know there's nothing else that's going to be within this class that's going to be a resume model. All right, so that's a long way of explaining what types are. So let's talk about now how we actually get the data out. And that's this right here. We're injecting something called an HTTP client into our component. And it's called HTTP. That's our variable name. It's of the type HTTP client, and it does pretty much exactly what you would think it would do. It allows our code to go out and talk to various web resources. And then down here, we're defining something called onInitialized async. So the components within Blazor have various life cycle methods that we can hook into. And so one of these are called onInitialized async. So it's saying, all right, the Blazor component is saying, I've been initialized, and here, now you can enter some code for me to do other things. And so, all right, we're going to enter some code in there, and that code is going to be the HTTP variable that we got injected before. We're going to say, get me some JSON. And then we're going to pass in the URL where we want to get that JSON. But note, the brackets, we're saying, you know what? Hey, get me some JSON. But that JSON file, we know it's going to be resume model. We know it's going to be that strongly typed. We know it's going to have the about string. We know it's going to have the experiences. We know it's going to have skills. We know it's going to have educations. This is telling .NET, use those classes that we defined before, populate them. We guarantee you that that file is going to fit. So now we have strongly typed files that we can use to go ahead and populate our strings with, or our components with. So now we get to render them. And that's exactly what we're doing here. We have 3 different ones, one for experiences, educations, and skills. And you can see that we're going through, like, for each experience model in resume.experiences, we're just looping through all the experiences that we happen to have in our resume. and then displaying them in an experience component or an education component or a skills component. Right here. We're just saying for each experience model, take that variable and pass it over to the experience component. Same thing with education, same thing with skills. All right, so now finally, let's take a peek at what our, in this case, our experience component would look like. Again, we're doing the at using types. And then we have a bunch of HTML here. And that HTML is just using this at data and then title, company name, and description to it. How does it get to it? You can see below in the at code block, we have parameter and then public experience model data get set. So we're saying, you know what? For my whole component here, I want to have somebody, the enclosing component, set the variable that I'm going to use to display data with. So if I jump back out before, you can see experience data equals experience model. So that data right here, that data property is what's being sent. And then I can use it further on in my component, the parameter, and then using it. All right. And then finally, of course, this is our resume and we want to make it look good. So we can use CSS to style things. So we can put CSS or cascading style sheets. We can throw it up in the W root and something called the app.css. And that's going to apply to application-wide, everything. However, if we want to just style an individual component, we can actually do that by, for the example, the experience one, we can do experience.razor.css, and whatever we apply in there, whatever we put in there, would only apply to that single component, which is nice. So really, we should be applying, if possible, the CSS as closely to the component which is going to apply to as we can. A lot of times that might be up into the app component if we have something, or the app.css, if we have stuff that's going to go application-wide, then it totally makes sense to put it up there. But if we have just special things that are only going to apply to experience, let's put it down to an experience.razor.css file. All right, we're here. Let's build up our resume application. So what I am going to do, I am going to jump out to Visual Studio Code. So I'm going to use .NET. I am running on a Mac. So I'm building .NET on a Mac. Don't need Windows at all. So what I have open below here is a terminal. And then what I can say, what I can do is just do ls to see what I'm on, and I'm going to do desktop. So I'm changing my directory to the desktop. And then I'm going to say .NET new, like we learned before, Blazor Wasm, and then -O for resume app. And that's going to create me a brand new resume app folder and all the files within it. And then I'm going to open that up. And I can see them all over here. And I have a pages. And let's take a peek at the counter page. I'll make it a little bit bigger. And you can see that I have page whack counter. Give it a title. And it's doing the exact same thing as we looked before. It has an on-click event, and here's my click handler down here. And it's just going up, click, click, click. And if I run it real quick, I can do .NET run, which is my command line variable to actually run the application. Enter. And then when it's done compiling, I get two URLs that I can copy over. So let's copy it, and then I'm going to go over to my browser, paste it in, go to my counter component, and you can see right here, it says whack counter, so I know I'm there, and then start clicking on it, and my components start clicking up. Pretty cool. All right. But what I'm really here to do is to build a resume component or a resume application. Oh, a resume component, really? So what I want to do is I could either go up to my pages and create just like another resume.razor, or I can actually have the .NET CLI do it for me. So I could do .NET, actually .NET new razor component -n for name, and I'm going to call it resume, and -o for where I want it to go, in this case, pages. And right here, it created a resume.razor for me. So the very first thing I want to do is enter that page directive, let's say, and we'll call it resume. So now I'm saying, hey, whenever somebody goes to whack resume, display this component. Now, I mentioned before, we definitely want to make sure that it gets into our navigation menu. So I opened up the shared folder. Now I'm opening up the nav menu.razor. And I'm just going to copy over what I had here for the counter. And instead of saying counter, I'm going to say resume. And for the href, I'm just going to say, again, resume for that. Now, when it opens up, then when my app runs, I'm going to see home, I'm going to see resume, I'm going to see counter. When I click on resume, I'm going to see my resume.razor file open up. So I'm going to change this to an H2. And then I'm going to put in an about. And I'm going to say about name. All right, so about name, let's create a variable to handle that. And so down in the at code section, I'm going to do string name equals Matt. So I have this variable, it's handling the name Matt. And now finally, I'll just do a .NET run to make sure everything is up and running. And it's all good. Back out to my web browser, refresh it, and you can see now I have resume. And I must have did something wrong because about Matt, oh, you know what I did wrong? I didn't save my file. Now, run this again, .NET run. Refresh, and I see about Matt. Cool. So the next thing I'm going to want to do is actually go and get my data. So instead of going through and trying to write all that JSON by myself, what I've done is copied it over into a file. So I can just do resume JSON, and then I'm going to put it into sample data. So I have it here. So you can see it has an about, it has an experiences, so company name and title, then it has education. So it's the same thing that we looked at before during the slides. Cool. So I'll close that and I'll close that. And so the next thing that we want to do is actually have a new folder within the pages that I'm going to call shared. And within that shared, I'm going to put in this types.cs file. So it's my types classes. And so I'm going to have my resume model, my experience model, education model, all that in there. So that maps up to the JSON I just put in to the sample data. Okay, so now what I want to do is actually get the data out of that sample data file. So first thing I'm going to do is do a using types. Great, and then I want to do inject HTTP client, and we'll call it HTTP. All right, and then I'm going to need to do a protected override, async task on initialized async. Now, hopefully I typed everything correctly, and we should be okay to go. Oh, before I forget, I also want to do a public resume model and call it resume. And so this will let me get at the resume further up in the page. So essentially what I'm doing is just creating a public variable so I can get at it later. And one of those ways I'm going to get at it is going to do resume equals http.get from JSON async. I know it's a resume model. And then I'm going to pass where I'm getting it out of. And that's going to be from sample-data/resume.json. So one thing to note is, and I also want to make sure I await it to tell it, you know what, it's going to be an asynchronous call. And so one thing to note here is that I'm just saying, you know what, sample/data, because that exists in my W root. And that's where eventually everything's going to run in. So I am going to just do a .NET build to make sure I typed in everything okay. And it looks like I did. And then I'm going to, underneath about, I'm just going to put in a div tag. And then I'm going to do resume.about. And then I'm going to say, instead of .NET run, well, I'm going to just do .NET run again. All right. And now I should be able to go back to my application. And there it is. .NET developer with a proven track record and a growth mindset. Now you see I have an unhandled error here. So what I should really be doing is making sure I have that. And if I'm really, really careful, I should be doing if resume not equal no to handle that. All right, cool. So the next thing I want to do is make sure I can handle my experiences coming through. So I'm going to make this first indented so everything is nice to see. So I want to make sure I have all my experiences. And so what it would be really nice to have is something like this, H3 experiences, and then a div with a class equals experiences, like that. And then how about something that would go like an if resume not equal to no, and resume.experiences not equal to no. And then finally a for each, and then resume.experiences. And then finally, I want to do experience data equals. That would be super nice to do right here, essentially passing in my experience. And I can do that. And the way I'm going to do that is .NET new Razor component. And I'm just going to call it experience. And here it is. And so here what I'm going to do is I'm not going to change it and call it a page at all, because it's never going to be I'm never going to navigate to it. But what I do want to create is a parameter for it. And that parameter is going to be a public. First, I want to make sure I do my using types. Tell it that, you know what, I want to be able to get at everything that was in my types class here. And it's going to be an experience model. And we'll just call this data. So, and then what I can do then is we'll do a div class equal experience here. And then I'll just do a bunch of H's. I'll do, let's say, an H3, and then we'll say, how about data dot. Let's see what's in my experiences. How about data dot title, and then we'll do company name and tenure. Data dot title. Oh, you know what? This is a good point. You know how I wasn't getting like anything type ahead? I had to put my @ symbols there. Like so. So that's a good thing to call out. So then I can do data, and you can see now my type ahead is showing me what was all in there. So I can say now tenure, like so. And then finally, I can say a div, and we'll just do data dot description, like that. So that is my whole experiences component. So now when I go back to my resume.razor, it should, should work for me. Let's see it. .NET Run, it's up and running. I'll go back to my browser, hit refresh, and you see I have my experiences in there. Great. You can see I also put a types.NET resume not equal to run. I should have did that to make it work a little bit better. But so I'll make this if block into my code with the @ symbol. But now I have all my experiences, but it's not super good looking. And that's where the CSS comes in. So let's stop it from running and add some CSS. So the first CSS I want to add is going to be this app CSS. I'm going to take it from my resume comment again and copy it in to here and say, yes, I do want to replace it. And then the next thing I'm going to do is take the experience.razor.css and pop that into my pages. So now I have that working as well. And so what I'm going to do here now is I'm going to say .NET Watch instead of .NET Run. So we'll get some pretty interesting things going on with .NET Watch. Aha, now we're up and running, and you can see we have different colors going. So if I go to resume, wow, look at that. It's now a little bit better formatted as before, but everything's black on black. If I change this now in experiences.razor to red, hit save, and then Control R, so rebuild. You can see I have everything going with red. So here I didn't have to actually rebuild the whole application. It just worked. All right, so we're going to finish it off real quick, and I'm going to add in to it skills and then the education portion to the shared. And then I'm going to open up the resume Razor file here so I can copy in this so I don't have to type everything out again. So what this is doing is just bringing in my education, bringing in my skills. And this question mark is saying, you know what, if it's null, that's cool. Don't worry about it. And then I should be able to go back out here, and you can see I have education with my skills below it. So that's cool. All right. Full resume app, up and running, up and built. We're all good to go. Back to the slides, and we did it. We made it through. All the way down, we have a resume app running in Blazor, pulling data all within components. And you can go check out these resources to find out more and take the student challenge to learn more about this. Go all the way through a bunch of Learn modules to test your challenges and learn more. And the GitHub repo with all the code from all the sessions, you can find it right here, github.com/microsoft/.netconf-student-zone. So my name is Matt Soucoup, and thank you so much for joining me on this journey for learning Blazor to display a resume app.
Great. Now that you're all set up with your portfolio website and your GitHub profile, we can take it to Krzysztof to learn more about IoT.
Internet of Things is so interesting. There's all these little sensors and little devices that will go and tell you about the world around you. And in this case, we're going to learn how to detect that our water bottle has had water drunk from it. How is Krzysztof going to do this? I don't know, but I'm excited to see how.
Hello, my name is Krzysztof Wicher. You can find me as KRWQ on different websites like GitHub, Twitter. So today I'll be presenting how to use IoT sensors with .NET IoT. So let's get started. So we're going to be building water consumption like tracking with .NET IoT. So we're going to build a prototype of a smart bottle. So we basically need to tell how much water was consumed. So like, how do we like start with this? Like, there's like, we know we need sensors. We know we need to connect them somewhere, but like, how do we actually get started? So like, it might sound like a bit intimidating. So I actually cannot show every single step in here. So I've actually posted like full detailed instructions on the website I mentioned in the slide. It's also will be mentioned on the last slide, and in a couple of places you should have a link for that somewhere. So basically, once you get on that GitHub page, search for using IoT and .NET, and that README page in there will have all of the detailed instructions. So let's get started. So how do we read from sensors and like what sensors are in general? So basically, sensors allow you to read different stuff, and like the way they communicate is kind of different depending on the sensor. So like in the specific pictures I've showed here, like I'm showing like in the right bottom corner, there's a BME 280 sensor. That's a pressure, humidity, temperature sensor. And like it has a bunch of pins basically, and like you can see them on the you can see the labels like basically over there. And like also the Raspberry Pi on the picture above that, it also has a couple of sensors like temperature sensors, and also has a couple of pins. So now like how do we actually connect that? Like we need to first learn about some protocols. So there are a couple of communication protocols, like they're called like I2C, SPI, and then there are some protocols which are described directly over GPIO. GPIO is basically like you change the voltage on a specific pin and you put it down in a specific sequence, and that works. Some devices work even on the PWM. PWM is like when you basically like cuts the time into like equal intervals, and some of that time will be filled out with like a high voltage, and some of that time will be filled with the low voltage, and like the percentage of that defines the in that specific time period, it will tell you like the PWM fill basically, and you can control like servo motor or something with that. So in this specific demo, we'll be just using I2C, or I2C, some people call it. So I2C has, like, I'm gonna simplify it and say 4 cables, but it's actually 2, and 2 cables are like one is clock, and the other one is, and the clock is called SCL, and the other pin is called SDA. That stands for something with data. They're sometimes called SDI and SCK, and also the other 2 cables are ground and the power source basically. Like the ground and the voltage, supply voltage. Yes, and like you basically connect it with 4 cables to, like in example, your Raspberry Pi. Like you have to find the datasheet and like find out which pins connects where, and that's it. I mean, I described it in more detail in the details in the README file. So in this specific actually picture, like I'm showing BMP 280, and this is BME 280 on the other. The real picture is BME 280, and the one on the with the lines shown, that's BMP. And they're actually differ by one letter, but it's different sensor. And they're similar though. The BMP 280 is actually slightly like a cheaper and smaller version of BME 280. They're very similar, but like one of them basically doesn't support relative humidity. So how do we connect that to your PC now? Like you say you don't have Raspberry Pi, but you would like to connect it to your PC. I mean, you don't have any pins obviously sticking out of your PC, so you need to connect it somehow. Like, so the way I usually do that personally, I use something called FT4222. So 3 twos. So FT4222 is a chip, and that's actually showed on the picture. It's that like black rectangle on the with like tiny pins around. The arrow shows that, and that chip usually comes on the board, and that board is called UMFT4222 EV-D. EV-D stands for Evaluation Development. So it's actually a USB device, and like you plug that into your PC, and basically you have pins at that point, and you can connect any I2C device. And I2C is actually really convenient protocol. I mean, usually, like lots of times when you work with sensors, you can work on the real-time operating system or like a microcontroller, basically, where you don't have an operating system which I don't know can switch context and basically give you a delay while you're communicating with sensors. So I2C is actually works pretty decently on the non-real-time operating systems, and because of that, that's my preferred choice when I'm working on like Windows or Linux. So yeah, like, and with this specific device, you can work on either Linux, Windows, or macOS, like whatever your preference is. So let's design our smart bottle first, and so the smart bottle needs 2 sensors at least. And at least that's why my design have. Yours can have different sensors, different specific choice of sensors. So like my specific design needs to know basically how much water you've drank. So we need some kind of weight sensor for that. And the very popular option for that is HX711. It will tell us how much we drink. Diego sponsored that sensor for me, like put his face over here. Thank you, Diego. And for the accelerometer can tell us different information, like in example, if the water bottle is moving, if you lean forward, basically, if you try to drink it, it will tell you like the list 3DH will, or like any accelerator basically will tell you like what's the angle of the glass. And because like the acceleration you will get from the sensor will basically have 3 dimensions in like 3D space basically. So like if you put it in a certain way, basically one of them will have 1 and the other other 2 dimensions will have 0, and the 1 will stand for the 1g, which is 1 gravitational force basically. It might be -1, it might be on different dimensions depending on like how you put the sensor in. So like I actually had list 3DH accelerometer on my box of sensors, so I use this one. You can use any accelerometer you want. For the weight sensor, there's a bit less choice in general, but actually, like you can find different weight sensors as well. Like you can use like force sensitive resistor basically, or anything. Like you can design it the way you want. This presentation will just show you in general how do you work with sensors. So like the design is your choice, of course. So we're obviously not gonna create a bottle. I mean, that's going to be way too expensive. Like we're gonna simplify this prototype, because we don't want to design like a full bottle with like double bottom basically, and that's just going to be really hard to design for the prototype. So what I'm actually gonna do here is simplify this. So we're gonna use glass and the regular way, and the way I will be able to connect that through I2C, I2C to my FT422 USB device, and the same goes for the accelerometer. So the accelerometer, I will actually use the tape, attach it to a glass, and that's it. And we'll be able to do some prototyping at this point. So this is how that looks like in practice. I would like to show you that on camera, but it's gonna treat it as the background. I will actually try. So that's my bottle. It's obviously you cannot see anything, but there's a. I'm trying here. Yeah, it doesn't work really well. But anyway, the picture shows it pretty well. There is the FT422 somewhere lying on my desk. That's the development board for the FT422, of course. And then the weight sensor, the HX711, that's actually a kit which is built on top of HX711. So it's not actually that sensor specifically. It's I2C device built on top of that. So basically, DFR robot created a device which put HX711 somewhere on the board. They put some other components and made it easier for use on the machines basically which don't have real-time capabilities. So it makes it way easier. And then the accelerometer is sticked up on the glass, like as seen on the picture. Okay, so we've assembled it, and now what? We need to write some code, of course. So my favorite language, C#. And then like I hope you have some experience with C# when I'm talking about it. It will be much easier. We have a .NET IoT repository which provides different libraries for different kind of sensors. So the list of all of the devices we support is on the website, which you can see on the slide. So it's github.com/.net/IoT. And once you're in there, you navigate to the source devices, and there'll be a README file with a long list of the devices. You just Control F on that page and search if you can find your device. We try to make it as easy as possible to find. So I hope you will be able to find whatever sensor you have bought. So the repository produces a IoT device bindings package, so it's also printed on the slide. So if you basically open like VS or do it from the command line, but if you open VS and do manage NuGet packages and search for IoT device bindings, that will be the package we're producing in that repo, and you will probably need the documentation, and so basically going directly to the repo will be very useful for you. And yes, it supports FT422. It supports the weight sensor and LIS3D-H, the accelerometer. Except the last two, basically the weight sensor and the accelerometer, they only supported from the 2.3.0 pre-release version. It's because I added them recently, just basically for the demo essentially. So yes, so you will need the pre-release version. So there is a checkbox in VS you will have to check. Okay, so let's do some coding. So if you haven't went to GitHub.com Microsoft .NET Conf Student Zone yet, go there. It will be easiest to start this way. So go to the using IoT and .NET page, and there is a starter project folder. So that will be the project where we start. So basically, it's based on the samples you can find on the .NET IoT website for both of those sensors. I basically joined them together into one sample. So like it's literally copy paste and just slightly adjustments. And but basically, the project does nothing other than set up for that sensor. So I will actually show you how that looks like. So it starts with the initialization, like searching for the FT422 devices. So we get a list of them. You can actually connect more than one of them. I kind of assume you only have one connected if you do it all. I mean, I've never connected more than one. I didn't even have more. So basically, if I find 0 of them, I will give you the message. Other, like if not, I will pick the first one. And now I have my FT422 device. So that FT422 device has the I2C capabilities. So basically, the way you work with the I2C is you create a device first, and that's why we work in .NET at least. So you create a device, an example like this, and each I2C device have an address assigned. So the address goes over here. Basically each device have a default address. It's sometimes you can pick one of couple of addresses. Sometimes you can completely choose the address of your preference. Most of the devices will either have exactly one address, or they will let you pick between 1 or 4 addresses, say. And this one is actually I2C bus. So if your device supports more than one I2C buses, so basically buses, those 2 pins SDA and SCL together, so that's called an I2C bus. So I mean the FT42 only has 1, so I believe this number is ignored, but like we always all samples pass in 0. I actually don't remember if this will make any difference. It doesn't really matter if you copy paste the sample from the .NET IoT page, like that will be your source of truth, like that's how you use that device. So you basically create two I2C devices, one for the accelerometer, one for the weight sensor, and these magical names, you will find them basically on the sample pages on the .NET IoT page. So now we have an I2C protocol, like access to the I2C protocol for those devices. But we also want to create the object which is responsible for that sensor. So in here, we were actually going to create weight sensor like this. And basically, we pass in the I2C device to that sensor, and it will know what to do with that and how to interpret that. The same we do for the accelerometer. I don't know why I've used var over here and not here, but let's change that. And so yeah, so you do create, and then you pass in some parameters. Sometimes this is actually optional parameter. We will change the data rate frequency to 100 Hertz. Will not produce more samples than this. And for the weight sensor, we need to calibrate it, and tar, which means basically the same as if you have a regular way and you press the reset button, it will basically make it so that every reading starts with 0 on regardless of what I've put on the way. So the blink LED is just like a feature of this specific sensor. It will just blink the LED. I feel it will work the same, except it will not blink the LED. But this way I can know that my program started physically and everything works. So now we have those 2 objects created, for the weight sensor, one for the accelerometer. And like if we want to read the acceleration or weight, this is what we do. And it's all in the .NET IoT sample. So the acceleration is the vector 3 basically, and it gives the acceleration in each direction, X, Y, Z. The way I oriented my sensor, the Z is the pointing. Basically, the Z is telling me the gravity at this point. So like by default, if I don't touch anything, the Z will tell me 1. That means that we're pointing down essentially. So and the mass, by default, it will give you something really close to 0. Like it might not be exactly 0. The sensor is not that accurate. And the mass is the units net. Like it's basically units net representation for the mass. And if you want to get grams, you can do grams. You can also do different units like grams. Earth masses, that's kind of useless in here, but you can pick any unit you want, so it's kind of not unit dependent. We can return mass and we don't have to think about the units at this point. So let's actually write down like really simple program while true, and it will forgot the break. Yep, and we will just put those 2 inside of the loop and like this. And let's print this out. So I mean, we can actually see what's going on. So if we now do console write line, we can display, say, press insert, acceleration, X, acceleration Y, and acceleration .Z. And let's do the same for the way. Grams. here. We just happen to have the same unit letter. This is also G, but it's a capital G because it stands for gravity, and this one is grams. So it just happens that this is kind of confusing. But like if we run this, hopefully we will see the output. So we just try that out. Okay, we are started seeing data. I hope this is not too small. Yeah, so we're starting seeing data. If I pick up the glass, we should start seeing negative way, like it's minus 290 now. And if I put it back, it's something close to 0. I can Control C the program. Okay, so now we have the now we have our weight and acceleration. And the reason I actually don't have to put any delays here is because the way is actually kind of slow. I mean, that's the way the protocol works. I mean, it's slow. It has to do lots of measurements and some delays. So and because of that, I don't have to put any delays, additional delays in the loop. Like if we did that just for the acceleration, that would actually be really fast, and you can actually see that. So actually faster than we can see. You cannot actually see anything because of that, but the way itself is like really slow. So but we actually would like to have it probably a bit faster. I mean, the sampling rate is not useful for the smart bottle. So actually the weight sensor actually contains a couple of options. We can speed this up. So there is sample averaging. So basically by default it will take 20 samples to even start to give you results, and basically like one sample is going to give you the result in like around 1 gram accuracy. So like if we do 20 of them, you should get around 0.05 gram accuracy. It's probably not exactly that, but it's probably much less from my experience. But if we change it, this value of to 5 rather than 20 by default, let me show you again like how the 20 looks by default. So it's 1, say, per second or something. And if we now change it to 5, this will run way faster. So this is actually probably enough to start doing any measurements for real. So for the smart bot, like we could probably speed this up if we made this smaller, like change some delays. There's other options here like read delay, but that's actually might make it the sensor less reliable and might throw exception because it never can get the it basically needs a bit of tuning to get it to work the way you want. So like if we change it to something smaller, it will also work. I found the 5 to be kind of a sweet spot between the speed and the accuracy, basically. So let's now do something more clever, like how do we detect the movement that we actually pour water or something. So like probably the first thing you should normally do is collect some samples. So like we could save this in the example to a file. Like we don't have that much time during this presentation to actually complete that. So I've collected the samples beforehand and I put them in the CSV file. They are in the repo under measurements. And if you start analyzing them, you will start seeing basically like different actions I've been doing. So like picking up glass, pouring some water, putting it back, then I drank something, and I basically recorded that to the CSV file. You can check that out. It's you can basically open it in a notepad or anything. And yeah, like start analyzing them, and you can see basically what I mean by samples. I can actually open one of those files right now to demonstrate this. Okay, so it's one of the files. Basically looks like this. It basically has raw samples. It's a recording. It has timestamp, it has way, and it has all of the X, Y, and Z. So this one actually doesn't. Yeah, I'm basically adding water while glass stays on the way, and I'm basically not doing anything. So if we look here, so up to around here, the way doesn't change. I mean, it changes by 0.1, but that's the essentially the measurement error. And then it starts increasing over here. Like this specific value increases, keeps on increasing, and then eventually it stops over here. So what we would like to detect is like basically this action, like that the user refilled the glass. So what we're searching for is like when the points when the measurements stabilize. So like we can see in here like the measurements don't change much. Like it's like very, very tiny changes. Like it might be, this might actually occur like something like this, where we can see like 0. Like even 1 gram difference we can see just from me putting my hand on the desk and like kicking it really hard, and it might trigger the way to show something. And the same we want to check when the measurements stabilize. So we want to see the like when the measurements start changing rapidly and when they stop. So we would really like to detect that. And the output we would like to see is something like user refilled the glass, or user drinks XYZ grams of water, or like user moved the glass and didn't actually drink anything or refilled anything. So how we would do that? So like first we should define some like thresholds, basically, like how much what's the values we want to start reacting to. An example, like if we defined grams difference, so basically like we can say like if we see the 3 grams difference, that's when we start reacting, and we can say, okay, this is actually when the action started. And we can do the same for the for like acceleration example. Like so for the accelerations, I'm actually gonna use call it really weird, but I will explain in a second why. So I'm calling it an acceleration distance, and like the reason I'm gonna call it like this is for the acceleration comparisons, like we have a 3D vector, and it's actually really easy to compare 2 vectors together if you use distance of 2 vectors. And like so basically, if my vector is pointing down, that means the glass is standing, and if I shift it even slightly, that distance will increase, because that you might point slightly to the side, or even the movement itself will create some acceleration. So basically, if that distance changes, like that's when we will call it, okay, the user actually moved the glass. So let's like we need to compare 2 values, like in order to see any difference, right? So we need to store like a previous value, which we claimed that was a stable value. So let's define that. So we call it last way, and we will read that from the sensor, basically, like just like that. Like that's not complicated. And we're gonna do the same for the acceleration. Let's call it last acceleration. Accelerometer acceleration. So we've stored the last 2 values, and now let's find out if the movement happens. So how do we do that? Let's remove that code. It's not going to be useful anymore for us. So how do we do that? So like let's start with defining the variable, of course. So the movement happened. Let's call it movement happened. And now what? So we want to check if the mass changed. So the way we could do that potentially is like an example like this. So we take the absolute value of the way grams. We subtract the last way, and we check. Actually, it's really smart about doing this. So we can check the gram difference now, and basically, okay, now if we just print this value, we start showing us stuff. So like, and it actually shows us true for some reason, and the reason is because movement happens when it's higher, not smaller. So movement doesn't happen, and let me press finger on the way. It actually changed to true. So we can see that code is kind of working, but that's not it. So movement happened also when in example the acceleration changes, right? So that's not the only condition when this happens. So let's check for the acceleration. So how we do that? So we can do vector3, and we say distance. We'll put 2 vectors here. So we do last acceleration, do the same order, and the current acceleration. So we do difference, but that's that gives us the value. So we need to check if it's higher than what is it, acceleration distance thresholds. So now it will react also to shifts to the glass. So even if I don't move my like even if I don't touch the way, I and I shift the glass, it will also detect that now. So I will not be demonstrating that. I mean, it's actually I cannot demonstrate that. So let me do this. So take the glass now, put it on the desk instead of the way. So the way is going to be okay. So it needs a bit of explanation first. What's going on? So we because the way changes, I actually cannot show you the acceleration, and because we are only storing the last way in the very beginning, we cannot actually see any difference. So let's actually change this code a bit and start reacting. So basically what we need to figure out is like when the action happens. So like how do we approach this problem? So first of all, like we need to define something we want to call when the action happens. So let's call it like action detected. And it would be really useful to know following information. So let's get list of samples as the input here. So this is what we want. It's not what we have yet. So we want a list of something, and we would definitely want a list of all of the samples of mass. We want the samples of acceleration readers. But what also would be useful is probably like a timestamp or something like that, so we can actually start recording this and we actually can see something about that data, because like without timestamp it's like really hard to look at this data properly. We cannot calculate anything mathematically speaking. So let's actually add that. So let's add that with the timestamp. So yeah, that's actually correct, telling me correctly. So what we want is the list of samples, and let's do the following. So let's define that we want timestamp. We want like say maybe let's start with mass, and then vector 3 for the acceleration. So that's what we want as the input. And now I'm not going to be writing that method right now, but what we actually want here is something like action detected, and then we're gonna fill this out later whenever we feel like this. But let's start with detecting this action first. So how do we do that? So we definitely know that when action starts, we need to know that action started and the action finished, and we need to distinguish between that. So like we already have this information. Why don't we just define the variable for that? So like something like action in progress maybe. So in the beginning, it's actually false because there's no action when we start the program. And like, how do we know the action actually started? So like, what do we do? So the way we can, an example, do that is following. So let's start with, we definitely want to do something else when the action is in progress versus when it's not. So we don't really know yet what we're gonna write, but it will look something along the lines. So we'll do something when action is in progress and something when it's not. So what we want is, like, if action is in progress and movement happened, we want to do something, and we actually want to say that action started. So we're gonna say true here. But is that it? Like, is it actually sorry, I meant opposite. So when the action is not started and the movement happened, that's when we start the action, not the other way around. So this here we will define like when action ends. When action ends, we will call our method somewhere in here. I will actually stop here because like we still have not enough information to implement this. So like how do we do this? So first of all, like in order to provide this to our method, we need to define this. So let's start with copy pasting the variable we want to pass in, and let's call it, oops, paste didn't work exactly as I wanted. Let's call it samples, and let's create a new array. So when do we want to start the samples? So let's not think about this part too much yet, but we know following, like this will change the state of action in progress, and we know if the movement happened recently. So what we want to know is like what we want to do is like when action is in progress, we definitely want to store the sample. So that's definitely what we want. So we call it samples. Let's add it exactly what it just was telling me. So timestamp way acceleration, exactly this. So it's told me really smart, like what do we want? So okay, now whenever action is in progress, we will be storing samples, and in here we should pass those samples here. And now after the action is done, so when action ends, we want to probably clear the samples because we don't want to reuse the same samples for the next action. So let's go ahead and figure out first following. Like we already know that this changes only in the beginning, right? When else should this change? So basically, we always want to see the difference between when last action, the last movement happened to the next movement. So basically, if there's no movement, we don't want to change this value. When there is movement, we want to change that. So that actually sounds pretty simple. Like, so let's actually just try that and see what happens. So basically, when movement happened, but let's just write down exactly what I said. So when movement happened, we want to start the last way, and that's a way. And we want to say the last acceleration is our the acceleration. We don't want to read the sensor twice. We want to have exactly the same values. So yeah, so we are starting the sample. We're seeing the movement happened, and now here, and we can even detect the action started, but we don't know how to finish it yet. Let's actually see if that works first. So actually, let's just put it over here. So when movement happens, we can say, okay, some action started. We can debug it that very simple way. Okay, so I start my program. And nothing happens for some reason. Let me try again. Oh, I know why nothing happens. It's because I didn't move the glass. So yeah, if I picked up the glass now and it says action started. So that actually works pretty well. So let's remove it. And let's try to detect when the action ends. So when does the action end? So first of all, like we have a couple of conditions here. So definitely the movement cannot happen when the action starts, like when the action ends. So then the next thing we would probably want here is check like how long the movement didn't happen, and how do we check that? So we probably don't want to react like immediate, like so if the movement stops, like we don't want to action to finish immediately, like that would basically trigger on and off events. Let's actually see what happens. So like if I put this now, action ended, like I will pick up the glass. I didn't even put it back yet, and it says action ended. So that's not what we want. So we probably want to wait, like give us, okay, let's wait like 2 seconds. So what we can do to check if like say 2 or 3 seconds passed, like we can store basically when we save the last way and last acceleration, we can actually add another thing here. Let's do last timestamp, and let's do the same date time now. So we can actually treat the date time now the same way as we are treating our readings. So we already have a current timestamp, and let's put this last timestamp is this. So now we have, I think, everything to finish this. So now if the timestamp minus if this timestamp minus last timestamp, that is total milliseconds, is more than say 2 seconds or something along the lines. I actually let's create a variable for that, so because we already have 2. So const what unit? I think it's double. So let's call it inactivity milliseconds threshold. Let's call it 2000, and let's put it over here. So now when like when 2 seconds pass, like we can say, okay, this is actually done, like the action. And let's try this out now. I'm picking up the glass now. I'm putting it back, and let's wait a second. And action ended. I actually got it way too many times that I wanted. Because and the reason I got it too many times is because the action ended, but we never changed the state of action in progress. So we want to finish the action here. So we want to say action in progress false, and we actually, let's just call this because we already have this method. And samples. We don't produce any samples yet. If you notice, actually we do produce some samples, and we already said we want to clear this out when the action ends. So okay, so we are calling our samples. Man, let's try this out and see what happens. So I'm gonna pick up the glass, put it back. Let's wait a second. Action detected. Okay, now we don't get multiple events. Let me put it up again, and let me put it back again. Okay, we have 2 actions. Two times I did it. I've seen it to be working. Okay. We can probably add some more protections in here. Like in example, we can check if the bottle is in a straight position also. So just to not get any false events. So like the way we check that, we could do something like this. Is bottle straight? So because we don't want to finish the action when the bottle is like leaning forward, and because I'm drinking too slow and basically we didn't detect anything. So we want to make sure the bottle is actually in the straight position. So we can get the acceleration here, and we just return following. So we can do absolute value and of what. And now I said that the z direction is 1 when the bottle is straight. So let's subtract that 1. This is actually float. And now it needs to be smaller than something, when like basically smaller than some small value. So say like 0.2 or something like that. So when that value is very small, that means it's probably straight. Like, I mean, we don't want to put it exactly 0 here, because that will almost never be true, because this is a floating point. So it's might be 1.00001. So let's put some threshold in here where we claim that this is fine. And we actually have that threshold. We already defined it. Like we have an acceleration distance threshold. If we need to use different threshold, we can define it as well. Let's start with this and see what happens. So basically, we also want to check here if the bottle is in straight position. So let's put the acceleration here. And now we actually will not get that extra action detected when I'm drinking glass really slowly but steadily, and like we are not gonna get that at that point. So at this point, like it seems like we have everything, maybe with one minor exception. So actually, we're missing one sample. Like if you think about it, so basically, when movement starts, we recorded the sample, but we didn't record the last wait. So basically, when you started, like say I picked up the glass, and before I picked up the glass was the wave was showing 0, and now when I started picking it up, we would get like, for a very short amount of time, we would get like a gram or 5 grams or something like that. And at this point, we're actually gonna record 5 grams first, and we are never gonna record the 0 grams. And we actually do want to record that, and so because of that, we might want to add the sample, which is last timestamp, last way, and last acceleration when we start recording. And that's actually going to be very useful for us to get the accurate weight. So the way we do that is simple. So we have samples, and we do add, and we do last timestamp here, last way, and last acceleration. And now we have all. Now we just need to detect the action. And like, how do we do that? And that's actually very simple. So let's start with getting the first sample. So the first sample is in the action measurements 0. So that's always in there. So like we will need to define the variable, and how do we split this list? So actually the way we do that is following. So you do datetime, datetime, first timestamp. We do mass, first mass. We do vector 3, and first acceleration. And I put a random comma in here. And now let's do the same, but let's do last. The shortcut I pressed to duplicate the line was Control D. So we will go action measurements. Oh my gosh, I cannot type. Measurements dot count -1. So I'm gonna do this, and now let's define the like how much way changed. So the way we do that is simple. We do first like way mass difference in grams. We're gonna do first mass in grams minus the last mass in grams. And that might seem like reverse at first, but the reason this is correct is like when we start drinking, actually that depends. Like, so when we start drinking, so there will be say 100 grams of water, and when we finish it will be 70. So when you subtract 100 from 70, which is first mass minus 70, we will get 30, and that sounds correct for that specific purpose. So actually let's print this out. So I'm gonna console write line, and I'm gonna do you've drink grams of water. Let's print this out. I'm actually gonna open the bottle at this point, and I will pour some water. Stopped pulling the water, and it says that I drink negative 83 grams. It's true because I refilled it. And now I will drink something. And I've drank 58 grams. I didn't drink the full glass, by the way. So now I'm just gonna move the glass a bit, but I'm not gonna drink anything. It says -2 grams. Okay, that gives us something to start with. So let's actually split these actions into 3, like drinking, refilling, and movement. And it's very simple. Like if the mass is larger than 0, it will be drinking. If it's smaller, then it's refilling. And if it's close to 0, it's movement. So let's start with the movement first, like movement or no movement. So we've actually already defined difference here of grams which we claim that the movement happened. Let's actually extract this to a method. So I did press Ctrl dot here and extract method. And I'm gonna call this method mass changed. I don't like the arguments it did here. Let's actually just do last way and way. Let's go here. And let's just do the same. Last way and way. And now that actually works because this was a constant which is available here. So we have a mass changed method. And now let's reuse the same mass method here. So like if mass changed, first mass, last mass, then we're gonna do this. And if not, you've moved the bottle. And here we're gonna do if mass difference grams is more than 0, then do this, else you've refilled. And we're gonna put the negative sign in here. And let's see if that works. So let's start. I'm opening my bottle now. put some water over here. I've refilled 137 grams of water. Fine. I will move the glass a bit. I will not drink now. I've moved the bottle. That's correct. Let's drink it. I've put it back. I've drank 50 grams. That's probably about right. I haven't drank the full thing. Yeah, it seems to be working. So that's it. I mean, obviously, you can do more stuff than we just did here. We could, like an example, calculate the duration of the action. So if we subtract those two, you will get the duration. If we start analyzing the acceleration as well, we can get like a range of the acceleration. We could get the maximum minimum value, and you can do different kinds of stuff. Like actually, Carlotta in one of the next presentations will show you like what you could do with this information. I will stop here, but actually the sample I've put on the GitHub repo page, that actually contains also like a range of the z value of the acceleration. The z is one we actually care about, and duration. But other than that, it's exactly the same, minus maybe some variable names differences. So yeah, thank you for attending this presentation. Like you can find more materials in the .NET Conf student zone using IoT and .NET, and it contains everything I've talked about today, even more than that, and more details. Thank you.
Thanks, Krzysztof. Now that we've got all that data from our IoT devices, we can kick it to Carlotta for a little bit of ML.NET training.
Machine learning. So we're going to use machine learning and artificial intelligence, and we're going to predict the future of our water consumption. That's going to be super interesting.
I'm looking forward to it. All right, Carlotta, take it away.
Hi, everyone, and welcome to the machine learning session of Student.NET conference. So today we're going to see how to use machine learning.NET framework to solve our water consumption project. So how to estimate water consumption and refill starting from accelerometer measures. I'm Carlotta Castelluccio. I'm an academic cloud advocate at Microsoft, and I mainly advocate for machine learning and artificial intelligence technologies. And in terms of people, I advocate for students and educators. So before digging into our problem of water consumption prediction that Krzysztof introduced with his amazing session with IoT sensor, I would like to do a step back and answer to the question some of you, I'm sure, have in mind right now. Why are we even talking about machine learning at the .NET Conf? Short answer to this is machine learning is everywhere. You use machine learning-empowered applications without even noticing it. When clicking on product recommendation on an e-commerce website, for example, when using the voice assistant of your mobile phone, even when consulting your navigation app to choose the best itinerary to reach a new place. And this is a growing tendency. In the near future, every applications on every platforms will incorporate some machine learning capabilities, empowering the application itself and making it smarter. If you think of yourself as a developer or an aspiring software engineer, you might see machine learning as a separate art, practiced by an elite of data scientists and statisticians, and you might be uncertain about how it fits into application development. But I'm here today to prove you're wrong. So machine learning is everywhere we see it. This doesn't only mean that it is embedded in every applications we use every day. This means also that most of the machine learning algorithms are designed to work similarly to how our human brain works to solve a problem. Take Kate, for example. Kate wants to buy a new smartphone, and she tries to calculate how much she needs to save monthly for that. She went over dozens of e-markets, ads, and articles on the web, and she learned that new smartphones prices vary between $200 and $1,000, depending on different factors: hardware performances, design and size of the smartphone, and also year of production.
After some time, Kate starts seeing a pattern. For example, phone with 8 or more cores, 6 inches display, and produced in 2022 cost more than $800, while phone with 6 cores, 5.4 inches, and produced on 2021 cost between $600 and $800, and so on. So in machine learning terms, Kate is applying regression to her problem. So she's predicting a value, which is the smartphone price, or better, the amount of money she needs to save to buy the smartphone based on known historical data. Now, an average Kate like me can keep all the data in her head while calculating the price, right? And here's where teaching a machine which does the job for us comes into the picture. So all the data collected by Kate around smartphone prices and functionalities is called, in machine learning terminology, training data. Training data is composed by features, which are all the different smartphone technical properties, like number of CPU cores, screen size, or year of production, and the label, which is what Kate wants to estimate, right? So the smartphone price. This data is the input of our model, which is trained on that to learn a pattern to extract from it. In technical jargon, the output of the model training is a function f, which embeds the relationship between the feature x and the label y. When using supervised machine learning method as a regression, which means supervised means that we start from a labeled dataset, a slice of the input dataset is held back for evaluation purposes. In fact, since we know what are the actual label, we can compute the difference between the actual and the predicted values to have a general understanding of how our model will perform on unknown data. Now, I introduced you to regression since we're going to apply a regression algorithm to our water consumption problem. But the machine learning algorithms family is really huge. And this sketch gives you an idea of where regression is placed in the classical machine learning algorithms context. And we are not even mentioning other types of advanced machine learning algorithms like reinforcement learning or deep learning, which are out of scope today. But now that we have an understanding of how a simple machine learning algorithm like regression works, let's apply and see all of these in action on our project. So let's recall our use case. Krzysztof collected data streams of acceleration and weight measurements performed by IoT sensor and aggregated the data by action, where an action normally is drinking a certain amount of water or refilling the glass of a certain amount of water. This amount of water is measured in grams. Now, we wish to train a model with this historical data, able to predict the amount of water drunk or refilled in grams during an action for which we don't have the weight variance, starting from accelerometer measures. So if we imagine that we start collecting unlabeled data of acceleration from similar sensor, we should be able to estimate the corresponding water consumption without having weight sensors. Coming again to features and label, we are going to train our model with features such as duration of the action window, so how many seconds the action of drinking or refilling lasted, the average acceleration on the 3 axes of measurements, which are X, Y, and Z, and the range, again, of the acceleration on the 3 axes, where the range is computed as the difference between maximum and minimum acceleration, to be able to predict the weight variance, which means the amount of water consumed or refilled during that action. The action ID is only a unique identifier of the action, so an incremental ID, and it cannot give the model any further information to learn. While the timestamp, which is the timestamp at which the action started, is not included again in the feature, and I'll explain the reason why in a few when we will go to our demo. So before digging into some C# code, let me introduce you to the tech stack we'll be using for this session. First of all, machineLearning.net, of course. This is also in the title of our session. This is a framework designed for .NET developers that wish to add machine learning capabilities to their applications. without having to leave the .NET ecosystem and with the possibility of writing code in languages they are already familiar with. Within this framework, you can both rely on automating machine learning, which is a technology that automates the process of building best performing models for your machine learning scenarios, and which is suitable for everyone, also machine learning beginners. Or you can build customized machine learning models and tune hyperparameters for more advanced scenarios. Then we will use the .NET Interactive Notebooks Visual Studio Code extension, which brings the power of notebooks, a popular tool in data science where you can alternate code chunks to markdown cells, into the .NET framework. Also, the added value of interactive notebooks is that they are polyglot, so you can write in different languages, C#, F#, SQL, in the same notebook. If you wish to learn more about machine learning.net and interactive notebooks, at this aka.ms link, you can find useful resources to kick off. Finally, we'll be running our interactive notebook on GitHub Codespaces, which is a developer environment hosted on the cloud and accessible via browser, with a familiar user interface similar to Visual Studio Code and the possibility to configure a dev container with all the configurations needed in your environment. So now let's jump directly on our GitHub Codespaces. Here we are. As you can see, the layout is very similar to Visual Studio Code, so it's very familiar. And let's start with the import of all the dependencies we'll need throughout the demo. So here you can see that we are importing in the environment, for example, Microsoft Data Analysis and DataView.interactive extension and NuGet packages, which are packages useful to perform data analysis and exploration in .NET. Then we have Plotly.net, which is a common library to perform data visualization, and plot interactive charts. And finally, we have Microsoft ML.AutoML, which we will be using to experiment using AutoML. Now, all these commands that you see starting with the pound here are called magic commands that we use to load the dataset from, a magic command is a scriptable shortcut to a more complex behavior, actually. For example, here we use them to load packages, while scrolling a little bit down, we use them here with the value and the share command to import the CSV file in the notebook environment and then access the data. But there's an object in the machine learning.net framework which is easier to access than these. And this object is the data frame object. Why it's more accessible? Because it's a collection of columns, so we can work with columns rather than working with a single object. And also the data frame has some common features for data analysis and transformation. This object is a very popular tool between data scientists. And we can load a CSV, we can convert these CSV data into data frame, but by just using this load CSV from string function. And now let's have a first look at our data frame, ordered by time, just to make it more readable. This data frame is a collection of 111 rows. And here we can recognize all the columns I showed you in the introductory deck. So we have the action ID, we have the timestamp, the weight deltas, and the aggregated accelerations. What we can see from a first look at this data is that the timestamp of the action, at least for the few rows, are very close one to another. For example, here we have 14 October at 2:47 p.m., then 2:48 p.m., then again 2:48 and 30 seconds p.m., and so on. So this is already information we can take from looking at our data. Probably the measurements have been done in a limited window of time, at least again from the first few rows. Also, we can notice that we have both negative and positive weight deltas, where a positive delta means a water refill type of action, while a negative delta means a water consumption. Also, there are some actions with the weight deltas really close to zero, like the first few rows, which probably mean that the user doesn't really drink any water, because having a consumption of water of an amount of water lower than 1 gram is very unreal. So probably the user just lift up the glass, for example, or it could be an error in the measurements. But just looking at the data in a tabular form is not really the easiest way to analyze them and extract useful insights. As pictures are often worth 1,000 words, similarly plots can reveal anomalies, hidden relationship between variables, and provide a unique understanding of the data. For example, here we just formulated an hypothesis, right? Timestamp of measurements are close to one another and placed in a limited period of time. Let's see if we can confirm our hypothesis by plotting the weight deltas over time. So to make it, but before doing the plot, to make it easy to recognize a water consumption from a water refill type of action in a plot, I would like to split the data set according to the weight deltas. So in one data set, I will collect only the element for which the weight is less than or equal to 0. And in the other subset, I will collect all the elements which have a weight greater than 0, so a positive weight. And then I will just combine two scatter plots in which I have the weight deltas on the y-axis and the time on the x-axis for the two subsets. So let's see the result. The plot have been executed with Plotly library. In the result, this is the resulting scatter plot. So here you can see that the orange data points are the water refill and the blue data points are the water consumption measurements. So from the result, we can immediately see that our guess was not so wrong. We have most of the measurements around 14th October here in a window between 3 p.m. and 4 p.m. During the day of 15 October, we have a lot of measurements in the window between 2 and 3 p.m. And again, we have quite a lot of data on the 18th of October, both for refill and for water consumption, in a window of time between 5 and 7 p.m. This probably means that we cannot extract a pattern from the time distribution around users' drinking habits, since we have data only for specific windows of time and for specific days. Another information we can easily extract here is how the weight deltas are distributed. So apart from a pair of points, the major part of water consumption is placed between 100 and 18 grams, while the water refill, the majority of the points of water refill are between 70 grams and 330. Great. So we already collected a few information from our first graph. Now let's move to another variable, like the window duration in seconds. Let's see if we can identify any correlation between the duration of an action and the weight deltas now. A first guess here would be that the greater the amount of water drunk or refilled, the greater is the duration in terms of sec of the action. But again, let's plot let's combine our two scatter plots, one for water refill and one for water consumption. And this time on the x-axis, I will have the window duration. And here's the result. Here's the resulting scatter plot, where again, the orange data points are water refill and the blue data points are water consumption. So for water consumption, the trend, for water refill, the orange data points the trends is quite clear. And is, let's say, confirm what we have guessed, because for a greater amount of water refilled, we have a greater duration of the action. So the data points are placed around a diagonal line. While for water consumption, the trend is less clear, and the majority of data points are placed in the quadrant where duration of the action is between 5 and 10 seconds, while the amount of grams that have been drunk are between 100 grams and 0 grams. So probably it's easier for the model to predict water refill starting from window duration rather than water consumption amounts. But let's move to another feature, another variable. Let's move to acceleration. In fact, the main objective of our project is really to estimate water weight delta starting from accelerometer measures. So let's investigate about any patterns existing between acceleration values distributions and water consumption. This time we're going to use a box plot, and we're going to plot on the x-axis the information if the action is a water consumption of a water fill, using the filter we used before, the Boolean filter we used before to split the dataset into two subsets. And on the y-axis, of course, we will have the average acceleration on the x-axis. Then we will see also the box plot for the other two axes, so y and z. But let's see the box plot for the x-axis. So for average acceleration on x-axis, we can see that the range of values between water consumption and water refill is quite distinct. We have a range of value between 0.2 and 0.3 for water consumption, and the range of value less than 0.1 for water refill. And this is a good news, because it means that potentially we can be able to extract from average acceleration x the type of action, so if the weight delta is negative or positive. And similar reasoning can be applied to average acceleration on the y-axis and average acceleration on the z-axis. So again, we can see that there are not overlaps between the range of acceleration for water consumption and water refill, which is a good news. Great, good job so far. So now that we have analyzed our data and confirmed some assumptions, we are ready to transform this data and to make them ready to modeling. Now, the preprocessing step to obtain the final dataset for training at this point are actually free. We will see them in a few. But first of all, the first thing we need to do in our machine learning project, now that we have explored and visualized our data, is creating a machine learning context. We will use this object to build our machine learning pipeline and then run our experiment. While this is just a function we have defined here because we will use it to transform the dataset and remove some columns we will not need. Now let's now move to the core of the transformation of the data. So as I mentioned before, we are going to do three types of transformation. First of all, we are going to convert the window duration into float, because the window duration now is a datetime format. But since we want to use it as a numerical feature, we're going to convert it into float. Then we are going to exclude the timestamp from the data, because we saw that probably we cannot extract any relevant information from the timestamp. And finally, we're going to filter the rows with an absolute weight data, an absolute weight value lower than 1 gram, because probably these measurements are just outliers, because it's very unreal that the user has drunk less than 1 gram or has refilled the glass of less than 1 gram. Last action to do before doing some proper machine learning experiment is, sorry, this is just, here I'm just displaying the data just to check that the data I'm using for modeling, just to check in the data I'm going to use for modeling. So I have the window duration in float and all the features I want to use. And then here I'm going to split the dataset into two subsets. As explained in the introduction, the training dataset, which is 70% of the data, will be used for training, and the remaining 30% will be used for evaluation purposes. Great. So we have now also our two subsets, the training and the test datasets. And so we are ready to create our machine learning experiments. So first of all, we are going to declare the features we are going to use. Those features will be all the features that we have in the data to model data frame, except from action ID that we say that is just an incremental ID that doesn't add any information, and the weight, which is our label. So these are this is the list of all our features. And then we're going to define our training pipeline. So in this demo, as a first machine learning experiment, I will show you how to build a training pipeline using AutoML. AutoML is a great tool, in particular for machine learning beginners, but also for data scientists wishing to optimize the time spent on comparing different models' results and tuning hyperparameters. In fact, AutoML, starting from the dataset and simple input, is able to output the best trainer and the best hyperparameter setup for your use case. Now, the input parameters are provided to the pipeline featureizer and are the training dataset, the features, the columns to exclude from features, while the auto.regression function here outputs the most popular regressors along with the default search space in ml.net that will be compared during the machine learning experiment to find the best one. The next step is configuring the experiment object. So here we're going to set the pipeline we just created, the training time, the dataset, and also the regression metric that will be used to compare the models, which is R² in this demo. So R² represents the predictive power of the model as a value between minus infinite and 1, where 1 means there is a perfect fit, 0 means the model is guessing the expected value for the label, and the negative R² value indicates the fit does not follow the trend of the data. So the model is performing worse than the random guessing. Great. So now we have all the steps we need, all the input parameters we need to run our experiment. And we can run our experiment just using the run async function on the experiment object. Great. So let's analyze the results of the experiment now. So first of all, what we want to know is which model type the AutoML has chosen. And in this case, the model chosen has been a fast tree regression, which is an implementation of decision trees. So tree-based models are a class of non-parametric algorithms that work by partitioning the feature space into a number of smaller regions with similar response values using a set of splitting rules, so if-then rules. And an advantage of decision tree is that they are efficient in computation in training and they are resilient in presence of noisy features. Great. So now, how good is performing this fast tree regression model? How can we know that? First of all, we can know that by using the predictions, which I computed here, applying the best model to the test dataset, so the data we hold back for evaluation purposes. And here we are going just to display the actual weight delta values, the predicted weight delta values, and the difference. So let's see our prediction. In the first row, how to interpret these results. So in the first row, we have an actual value of minus 81.9 grams and the predicted values of minus 82.8. So the difference is the error, let's say, is 0.9. Here the error is of about 2 grams, here about 2 grams and 5, etc. So for each rows, we have the amount of difference between the actual and predicted weight deltas, which already can give us some information about the performance of the model. But as you can see, it varies a lot between one extra and another. So how we can have a general understanding of how well or how bad our model is performing, and not just for one specific measurements. So first of all, we can rely on the R-squared metric, which is the metric the AutoML used to identify the best model. And we got 0.84, almost 0.84 here, which is a very good score if we remember that the ideal score, which is also unreal, of course, is 1. However, it's always a good practice to evaluate a model using different metrics, since a single metric can sometimes lie and does not represent the real quality of the model. So let's also consider a loss metric. The loss metric, let me zoom it a little bit here. So a loss metric is useful because it means it is in the same unit of the label. So in this case is in grams. And this value, 29 grams, means that our model on average makes a prediction with a margin of error of 30 grams, which is not so good, but even not so bad. If we consider the size of the data set, we had 100 rows, the amount of preprocessing we did, which was quite small, and the fact that we are estimating water consumption only starting from historical accelerometer measures. So my experiment will stop here for today for time constraints. I just want to conclude here saying that I'm saving here the model as a zip file in a way that it can be consumed by other applications. And since this notebook is available on the main GitHub repo of the StudentZone.net conference, which is this link you can see in this deck, I really encourage you to go ahead, replicate the experiments, and do further experiments starting from this notebook. And here you can also see other useful links. For example, you have the student tab with all the student useful resources like Microsoft Learning Path, Adobe for Students, or also how to join Microsoft communities. And here you have a link to join the Cloud Skills Challenge, which is a gamified learning experience in which you can also win very cool .NET swag. So go ahead and register. So thank you very much. This is the end of my session today. I really hope you will enjoy the rest of your .NET Conf day, and see you soon. Bye. Thank you.
All right, so now we've detected our water consumption with IoT, and we're tracking our future consumption with ML.NET. But what's next for us?
So Chris Noring is going to talk about adding a back end to your website. What's a back end? It's the opposite of the front end. The front end is the app that sits in the front, or the website that sits in the front, and the back end is going to be that broker, the thing that talks between us and our data, our database or whatever. So the back end is going to use an API in a new style, a minimal API. These are super fun and way easier to write than in the past. So we're going to learn all about that from Chris Noring coming up.
And don't worry if you've never built an API, Chris is going to talk you through the whole entire thing.
Hey, folks. Welcome to another session on the student track. My name is Chris Noring. I'm a senior cloud advocate at Microsoft. In this talk, we'll talk about something called building an API for water consumption tracking. Now, there's a story that you all hopefully have followed so far. We have been talking about water tracking and water consumption, because you know what? Water is expensive these days, right? Our electrical bills are just shooting up the sky, so we do what we can to keep that consumption down. So our story so far is working with IoT, that's Internet of Things. We have a device out there with sensors, and those sensors are measuring exactly how much water you use for your dishes, for your shower, or for whatever water purpose that you have. And what we know so far is that the IoT device have been able to produce CSV files with a lot of columns in it. Not all of these columns human readable, but we will address that as part of our talk. So our next step in this talk is to transform that CSV file into database tables. Once we get there, then we will create an API. And that API will serve data from a database that we have constructed earlier. And the last bit in this presentation is to deploy this API to Azure, to the cloud, so that you're able to talk to it from wherever you are in the world. So yes, quite ambitious talk in 30 minutes, but don't worry, hopefully you will understand the high-level things of this talk and feel empowered. This is really a journey that takes you all the steps from once you started with your IoT device to the cloud. So let's begin. First off, we have a CSV file. This is coming directly from the IoT sensors. Some of these columns make sense if you look at them, like time, window duration, weight. Well, weight and everything else is like X and Y and Z and X again, and then some other Y, right? All of these are like sensory positions, like in 3D. And maybe you as a consumer of water, you're like, okay, you got an IoT device out here, right? You have a sensor, but I'm a consumer. I want this in liters or whatever, metric that I'm using to measure consumption. I don't want to know the position of a sensor device. So what do? Well, you start talking to your data science team and say, hey, data science team, how do I make these columns make sense in my reality, in the customer reality? Well, they can do some processing for you. The only thing they are telling you is that, hey, Chris, start creating this table. Let's call it water entry, and let's create these 3 columns: ID, date time when this measurement was taken, and lastly, consumption. Now, consumption is this column that's going to say it's a human readable value in liters that would tell you exactly how much you spent. And it's an interpretation based on all of these, I believe, 6 different columns that we measured from the IoT device. So that's how we make that make sense. Imagine now that we've done all that work, we talked to our data science team and they have transferred this data and they said, like, Chris, we're ready if you're ready. And I'm saying, yes, I'm ready to create that database table. Before we get as far, let's just quickly talk about APIs in general and the things that we think APIs should be able to do. One thing is routes. Routes are logical areas of your application that should handle things. So a route could, for example, cater to users, could cater to orders, invoices, different things in your API that needs a separate area and its own handling of things. The other bit is a data source. You want some kind of data source so you can persist your data as you do changes to it. That could be a database that we're going to use today, but it could also be something such as a message queue, or you could just shoot off a web request to some other system to deal with storage. Another thing your API should be dealing with is authentication, because you don't want anyone to just access your data and do whatever with it, right? So yes, we will look at some level of authentication today. Maybe not as good as you would expect on a production system, but you will definitely get an idea of what we mean when we say authentication. Lastly, the thing all good APIs should be having are logging, because you want to know how well is my API doing out there in the production server, either in your basement or in the cloud. Logging will add that insight. It will add things such as how is it doing, any problems, any errors, anything else going on. We're not going to add logging to our API, but definitely consider adding it in various places in your application. So what's the game plan? Well, we have 3 steps that we think about this. First off, we will use something called Entity Framework. And Entity Framework is a framework that lets you work with a database. Because guess what? If you're a student, I am sure most of you have encountered SQL, right? The language that we use to create tables, to insert data, and even to update various things. We won't write a single line of SQL today, thanks to the fact that we have Entity Framework, which allows you to do what? Write C# code instead of SQL. That's a win in itself, right? We will use it initially with SQLite. That's a very nice file-based database that works fantastic for our development purposes. But as we move towards the cloud, we will need to look at something more robust. The next step in our plan is to define. So we need to define our database, and our database should have at least one table in it so that we are able to store things and we can read from the database. Lastly, we're looking at how to integrate Entity Framework with our API so the two is able to talk. So once a web request happens towards the API, we are able to go down into the database, fetch the data, transform it into JSON, and present it to you, dear user, so that you're able to use something like a Blazor application or maybe JavaScript frontend to display the data in maybe a graph or however you want. Sounds confusing? It's not. Don't worry, I got you here. The first step in our plan is to scaffold the API. And good news here, we can use the .NET executable to do just that. And via .NET New, we're able to select a template. Looking here at our right, we see that we're going to use a template called Web. This will scaffold up an API for us. And we also need to tell it that we need the .NET 6.0 version. Are you not on .NET 6.0? You should be. What you see on your right side here is the generated code. This is all the application code that you need to care about as it scaffolds the entire project. And believe it or not, these 4 lines of code is all you need to create an API that tells you, hello world, should you be starting up this API? So yeah, things have gotten way more simpler since I started with development some 15 years ago in the former Ice Age. So yeah, now you know how old I am roughly if it doesn't show. So yeah, piece of code here that's of interest. This is when you map up something called routes. We mentioned route as logical areas in your application. This is how you do things to map up at least one route. If you need another route, call map get again. This time with a different argument. Instead of slash, you might call it slash products or what have you. App run, this is the command or in code that you invoke to start up your API. So this will start it up at a certain port. Once you connect to that port, you should be able to see hello world. So that's how we get that API up and running. Entity Framework. Entity Framework. You never heard the name before? Well, don't worry. I will take you through why you should be using it. And let me first talk about what it is. Entity Framework is an ORM. And if you had never heard that term before, it stands for Object Relational Mapper. This is a piece of software, a framework that sits between your application code and your database, so you don't have to type SQL. Does that sound interesting? What, you love SQL? Well, to be fair, I've done my fair bit writing pure SQL code, so I have nothing against it. I just like the speed when I'm using a framework. But what Entity Framework does for you, what ORM frameworks does for you in general, is to help you with creating of data, creating of tables, read that data, update that data, and delete data. And we call this term CRUD. It will also help you with something called seed. Now, seed is initial data. There's a lot of systems out there, databases that need some initial data to even work. So imagine that you have an invoice system. For you to be able to work on that invoice system, you might need some tables to be populated first, right? Like a customer table, because you want to know who should you send that invoice to. So that's the type of data that we can define inside of a seed. I will show you how to do that as well. And lastly, migrations is a very interesting area. And why is that interesting? It is interesting because guess what? Databases are not a stationary thing. They are changing over time, even after you deploy them to production. To make sure you do that in a predictable way so you can both apply changes but also take them back because errors happen, you can define something called a migration. And a migration is therefore an increment that shows the change that you aim to do. So that could be adding a column, adding a database table, or adding a piece of data. And you also want to define an operation that helps you to go backwards, right? So I'm going to talk about that a little bit more shortly. Next step here is to define a data model. And well, all good databases starts with some good planning. And what you want to do as part of that planning is to identify the major entities and understand how they interact with one another. In this system, it is fairly simple to start out with. We are only going to care about this table here, or this entity called water entry. This is where we store all the different measurements. But in the future, it might have other entries in it, like customer table or maybe an invoice table. So just imagine how the system grows from this fairly simple database to that containing many, many tables along the way. Right, so I promised you that you didn't have to type a single line of SQL code, and I meant business. So how do you do it instead? If I don't have to type create table something something, what do I do? Well, you create this class instead, and this class, in this case, we call it water entry. And what I want to put your attention to is the fact that Entity Framework handles defaults for you if you know what the defaults are. Meaning that if you create a column, for example, with the name ID, it will create this as a primary key column, which is awesome, right? You don't need to specify that this is a primary key. This is the unique key that a column would have in a data table. All you need to do is to name it ID or water entry ID, and Entity Framework will know exactly what you're up to. Looking here, I said that we needed to define our entities or our database tables inside of a specific class. But when it comes to the database itself and what's accessible, what you can query, what you can insert into, you need a database specific class just for that. So in this class here, we are inheriting from the DB context class. When we do that, our system knows that we are dealing with a database. And once we create this DB set entry, this is a table that you will be able to interact with, meaning we will be able to read from it, but also write to it. So you see how that works. Just make sure that the type is of type dbset, and just chuck your water entry entity right in there, and it will know that it will need to create a table from that. Right, so okay, we have so far talked about how we can model our situation, how we can model our database. We have talked about how we create various structures using C# classes, and Entity Framework knowing how to interpret that as database tables. But how do we get there? Well, yeah, the first step here is to add a package. And because I told you that we will all do this locally at first, we will add SQLite, a very popular file-based database for your hobby projects, but also for your small business projects. I wouldn't use it in a big production environment if you are scaling in the cloud or using Kubernetes or something really fancy and big like that, but it's definitely perfect to start out with. And also because you're choosing Entity Framework, it's fairly easy to switch between SQLite and Azure SQL, for example, that I will show you later in the talk. So once you've installed that package, you need these tools. You can install them via this .NET executable here. Once you install them, what you're getting is a tool set that will help you do design time development tasks, such as creating and applying migrations and generating code to create and update your database. So really, you want that tool set. And lastly, you want a package here called Entity Framework Core Design, which will help you further. Once you have those three, you have a very nice setup, and you are kind of ready to make everything work locally. I hope you're with me so far. Now we're gonna move into a bit more things. So we know how to define our database, how to define our tables. We've installed all the different packages and tools we could possibly need. So what's missing? Well, we need a way to connect to our database. So we need to point to wherever that database lives on our system, so it knows to connect to it and read from it. To do that, we need first a defined connection string. And here we are going in and saying we want a file here called waterconsumption.db. If it doesn't exist, definitely create it for us. Once we have created that connection string, our next order of business is to add the capability. We need to instruct the API that we need SQLite to be able to work with this. SQLite will give us that capability, as I said, to work locally. And the next step is to create a migration for all of this. And what we do to create the migration is to, first off, call .NET EF migrations add, and then provide it with a name. I call it mine initial create. You can call it init or whatever good name. Know though that this is the first migration that will be applied. So it should contain things such as how you create your database tables, your columns, and your initial data that you want. So once you've created that, what happens? Well, if you look here on the right side, you see that it has created this file for you. Normally, this is populated with a bit more things, as what it does initially is to look through in your project to see, does Chris have a class that inherits from DB context? If that's a yes, it's going to inspect that class and look for any other entities, and it will populate both the up and down method here. But the main reason I'm showing you just a skeleton of what a migration looks like is because I want to talk about what these up and down methods represent. The up method represents you applying changes. So in our case, that means creating a table, creating the columns, creating the data, and the down method means the reverse. The down is really a way that Entity Framework says, well, if I were to undo this operation, what would I need to do? If up means that I create a table, the down would mean to remove a table, right? So know that the migration can be run in one of two modes. So once you apply migrations, up is what will be run. When you want to revert and remove them, the down operation will be run. So hopefully you understand from a conceptual level why we have these methods. So what's next? Next is to apply a migration. To apply a migration, you can see here a little bit more in detail what it does. We apply a migration by calling update. And the way we do things here is first to create a table. That makes sense. And then we can also insert data. So we can do both at the same time. So what's next? Well, we want to add some kind of seed data, especially if we work locally. When we add seed data, you can see here that we are instructing the system to say that this is data that you need to hold at all times. That's why we use this has data method. Once we've done that, the has data method, we are kind of in business. So once we generate a migration from this, it will have a look at the seed method and say like, okay, I'm gonna take whatever you're saying here and move that into the migration as I generated for the first time. Right, and then we need to instruct somehow where the seed should be applied, and this is part of the constructor, or sorry, it's part of the on-model creating method that gets run when you instantiate the water consumption DB for the first time. You can see here how we have our initializer, we call the seed method, and that means it's being called right after the database is being created. And yeah, what we also need to do is to add a route. We add a consumption route here. And we also inject the database like so, and we're able to respond by calling db.waterentry.list. This is how we respond back to a calling user with our table here called water entry. And this will provide the answer back in JSON back to our user. So what about deployment? This is a fun chapter, right? I've talked about how these things work locally, but what about production? Well, there's a fantastic service on Azure that a lot of people are using. It is called App Service. That is something that you can push your application to. And then we can't be using SQLite in production, but we should rather aim for a database made for the purpose. For the intents and purposes of this demo, I will be using Azure SQL Server. You could be using something like Postgres or what have you instead. But if you are using Azure for Student as a subscription, Azure SQL Server is part of that, so you don't need to worry about costs. And what about security? I said I would talk a little bit about security. Well, with security, we're going to use an API key, and we will demonstrate how that would work. But yeah, looking at the connection string, you can see here how it changed slightly. you see that instead of our connection string talking to a SQLite database, we are instead asking for the connection string from the app settings, and we're doing something else. Look here how we call add SQL server. This is us adding the capability to add SQL server instead of SQLite. So this is us saying that there's a database here in the cloud. It is of type Azure SQL Server. That's what we're going to use instead. And here on the bottom half of our slide, we see that we need to define a connection strings section in our app settings. And we see that the value is not set yet, but we will set it. And this value will come from the Azure SQL database that we're about to provision. So before you deploy this live, remember to replace the value here for the DB key. And what about security? Well, the way we will handle security for this time around is to rely on a header that the user needs to pass as they make the web request. We will call this header key .NET Conf student zone, and we will expect you to provide not only a key, but also a value. And you can see some code here in which we compare the value of the key that you sent to the secret that we know. And if the two matches, you can see here how you get a to-list version of water entry back. That means that the table with all its content, or you're told 401, which means you're not authenticated. You will not get any data from me. Great. So how does it look then from a cloud standpoint? Well, if you go to portalazure.com, you need to first provision a SQL server. Once you provision that SQL server, you need a database. The good news here is that a SQL server can hold many different database instances, but you need that initial SQL server. Once you've created your database, you need to create the tables and insert the data, but you can actually use the tools within Entity Framework to generate SQL code from it. So don't worry, you don't need to type anything by hand. I promised you that. But you can definitely leverage the toolset from Entity Framework to just, instead of migrations in code, you just ask it for the SQL version, and this is what you're pasting into your query editor in the cloud. A next order of business is to go into that resource for your SQL database, copy that connection string, assign that value to app settings, because as you deploy your application to app service, your app settings will be synced to your cloud resource. So all of those values will be in the cloud. And yeah, one thing you need to do is to enable Azure resources to access your database. This will make your API work. So that's kind of good to know. And you, of course, need to deploy your application using app services via Visual Studio Code. You would right-click on app services and create a new web app, follow those wizard instructions, and your application is now working and it's able to talk to that database in the cloud. So yeah, let's show this in a demo, how this would work. First off, we have our source code here. You can see our API, and you can also see how I grayed out or commented out local things that we're not using anymore. This is SQLite things that we're not using, and we are instead relying on the connection string that we have in our app setting. You see how we're not using SQLite, but SQL Server. And yeah. And there's also a piece that I wanted to show, and that's part of the database itself. You can see that we're no longer calling the initializer and the seed method. That's not something we do once we're in production, so that's a thing we removed as well. One thing we want to do, though, is test that this works. How do we do that? Well, here I'm using a tool here called Advanced REST Client. You could be using something like Postman. And I should say that this database is in a serverless mode, which means that it has powered down. So I kind of expect this call to not work if it has fallen asleep. And me calling send here means that this database is fully asleep. So we're going to let it be for a second and let it wake up. And we expect it to error out the first time because it takes a couple of minutes before your database is provisioned again. So yeah, let's just talk about things that we have here. One thing I wanted to call out was the server here. This is our SQL server. Remember I said we only need one of those. So this is the server, and this server has at least one database. You can see that here. One thing that we could do with our server is to look at various settings, but we're going to go back one. And let's see here. Yeah, and there are various settings here that you could definitely be tweaking and figuring with. Let's go back to the server, because one thing I wanted to show you is the various settings that you could have. Let's see. Right. So now you see the left menu a little bit, and that's what I wanted to show you. I want to show you the networking part of different settings for different environments. So for example, for your local development, I would need to actually open the firewall, and this is me testing my API locally versus a cloud resource. You shouldn't have this in production for longer than testing purposes. As soon as you're done with your local development, remove this exception to the firewall. But one thing you want to enable is this: allow Azure resources to access your server. This enables your API to work. Let's see if this has woken up. Ah, look at that. We actually got a response back from our API. That's fantastic. That means our database has woken up. And look here how we are providing this header with a value. So it's actually allowing us to provide some data. But don't believe me. See what happens if I provide an erroneous value to this key and see what it tells me. See, if I do this instead, it's giving me a 401, right? It says, I do not recognize you. You are not Chris. Go away. I will give you a 401. But if I'm pasting back the correct secret value here, my route should be working, which it does, right? So these are my consumption values. Look here, I used 110 liters of water for my shower project or whatever kind of project I have. So awesome, right? We have brought you all the way from the IoT devices to the cloud. And let's see where we are. We are at the end of our presentation, folks. So I just wanted to thank you so much for listening here today. If you feel like this was a lot at once, just know this. Check back on the other talks, see how far once we've come from IoT device with its sensors to actually creating an API, creating that database locally, creating it in the cloud, deploying it. And just know also that we added various bits of authentication here via the API key. So that's how you do it, folks. You go all the way from IoT device to something that's usable, to something that's readable by the end customer, so they understand how to adjust their behavior using water. Thank you so much for listening. My name is Chris Noring. Bye for now.
Thank you so much, Chris. I feel like I learned a lot about how to make a minimal API. That was my first one.
Yeah, it's pretty cool. And now that you have a back end to your website, what can you go and build on top of it? You can build a mobile app. You can build any kind of app. We're going to build a mobile one using .NET MAUI. Someleze is going to show us how to do this.
All right, take it away.
It is so amazing to be part of the .NET Conference 2022. And what's more is that I am at the student zone with everyone, and we are trying to show you how to actually build a solution, an end-to-end solution with those different parts of .NET. My name is Someleze Diko, and I am a cloud advocate at Microsoft. And today I have a little something for you. So today I want us to be building a mobile application to track your water consumption using .NET MAUI. If you've never heard about .NET MAUI, this session is actually made for you. And please also note that this actual session is following other sessions that we already have. So for an example, the one that was using machine learning models, we are going to be loading that model onto our application and consuming the data from that and doing some little bit of predictions. So hopefully you're following along with other sessions as well. And let's just jump right into it. So today we will just look at what .NET MAUI is, just a basic overview. As you can see, the pictures here is you are able to build your own mobile applications, and they are cross-platform. That's one thing I really like about .NET MAUI. And then right after that, after we've spoken so much about what .NET MAUI is, we will look at how we can actually build a mobile application to track your water consumption. So what is .NET MAUI? And what can I actually do with .NET MAUI? So .NET MAUI is the most productive way to develop native applications that perform great on any device that runs Android, iOS, Mac OS, or Windows from a single code base. So think about it this way. You are writing code in your C# and in that specific moment, you are actually trying to code for multiple devices. So this is when .NET MAUI actually comes into play and how you can actually utilize it. I don't want to talk too much. You will see how we actually build a mobile application from scratch using .NET MAUI. And also with .NET MAUI, you actually are able to have a productive environment and maximum code reuse. So obviously, if you want to reuse your code, you can reuse it within .NET MAUI and within the applications that you build with it. And also, you would have native performance and integrations. Like I mentioned earlier on, how awesome it is to be able to build for multiple devices at the same time without having to going to learn other technologies to either specifically build for that specific device. Instead, use .NET MAUI to have a native performance and integrations. Also, there is an expansive ecosystem. So that is one key thing within .NET MAUI, its ecosystem. Let's look at the .NET MAUI architecture for a bit. So you have a shared code across all those different UI elements, the resources, the platform features, and business logic. What you only do here is actually write your code in C# and it will properly interface on your iOS device, or properly interface on your Android device, your Windows device, and your Mac OS. So this is how the architecture actually looks like, because all the applications that you're building with a .NET MAUI technology, you are able to build it using C# and it will be speaking across to all those different kinds of devices or operating systems. And you're using shared code for all of the UIs, the resources, and the platform features. You don't specifically need to code for something for Android. You don't have to specifically code something for iOS. You actually code it once, and all of those elements will be used by your application across the board. Right, how does .NET MAUI work? First up, everything starts with your code. This is where you want to spend all your time being productive. And you want to deliver your app on 1+ devices, so more than one of those devices. You want to deliver it on an Android device, iOS device. And next up is that the first layer of your technology is actually Cake, which is a native platform SDK. This is what Google, Android, and Microsoft ship for those platforms using .NET MAUI. And next up, you know and want to understand, how do we get from .NET app code to those platforms and running on devices? Right. First, we need something that can run the code, the .NET runtime. Yes, it uses Mono VM on mobile and Mac and Core CLR on Windows. But that's not terribly important, because next up is that we need a common .NET class library. So within the common .NET class library, you are able to write your code against, and that's the base of your class library, which is called the BCL as well. So it's also new in .NET 6, and the app runtimes actually use the same BCL or the .NET base class library. So obviously this is a bit confusing for you because you're starting off with .NET MAUI, or you already started on your journey, but obviously you haven't heard of these terms. Right, so to use .NET against native platform SDKs, we need a .NET representation of them. We need to do this via a binding a .NET API and implementation to the native API. And when you call the native method from C#, it's just as if you had done it from Object-C, Swift, Java, Kotlin, or C++. And again, like I mentioned earlier on, when you are building for those devices, you would tend to actually learn this technology separately. But whereas when you come with .NET MAUI, you're able to actually use them. You're able to actually build once for all of those technologies, right? Then the final layer of the cake, which actually really makes our application, is that .NET MAUI and .NET MAUI applications provide a rich library of controls, layouts, and services that work across all of the platforms supported. So you need to only master one API to get your native applications. So this actually makes the entire learning journey of your .NET MAUI application resources or your journey much more delicious than it is when you are looking at single technologies for those single devices. You are able to build one application that will be interfaced across Android devices and also interfaced across your iOS and your Windows phones. So next up, I know I've been talking so much and talking all of this technical gibberish and you probably didn't understand. So how can we actually fix this or fit this into our specific theme for today, which is building or consuming water consumption data? Right. We're on Visual Studio and we need to actually make our application work. So in this case, we actually want to see how we can be able to display data that is from our web API that was built by Chris. And also we want to see if we are not able to actually send some information back to the web API. So in that case, that's when you want to actually manually add your water consumption onto your application. The question is, where do you start? So when you get to Visual Studio, so unlike me, you'll have to open up Visual Studio and start it up for the first time. And in that case, you will start up a new project, choose .NET MAUI app. And then in that case, you give your application a name and all of those following steps afterwards. But if you can't find .NET MAUI, you will have to install those dependencies using the Visual Studio installer. Right, enough about those chit chat. So if you've done that already, you are coming onto your Visual Studio and you'll see this demo and how we can actually display data from a web API and also how to send data to that web API using .NET MAUI. It's a mobile app in the sense, right? So your first thing to do, so in my code, because I don't want to take up a lot of time when we're doing this, is that I set up my code in a specific manner called the MVVM. In this case, this is where you're looking at model view model. So you want to have a much more better control of your code and you want it to be much more cleaner in terms of your solution. So my homework to you guys, because I don't want to get into the great details of what MVVM actually is in .NET MAUI, you should go and research about it and try to see if you can't implement it on your side when you are trying out the solution. So let's get right into it. In my code, I actually have a few folders here. So in this case, I have a models folder, I have a view models folder, and I have a views folder. So what do these folders actually do? So in my models folder, I actually have a consumption model or a class. So this class actually just has a schema or stores the data of how our actual API looks like. So I have a property for an ID, a property for consumption, which is how much water we consumed, and then the date of when we actually consumed that water. So those are important in terms of how you name them. If you have a web API and actually has properties named in a certain way, so for an example, if the consumption is not consumption but consumed, you would need to make your schema of your class to be mimicking or resembling exactly what your web API looks like, or else it's not going to work. So it's very simple. You set up this class and it's going to work for you. Then your next step, once you have another folder, is to actually set up the view models for your code. In this case, I'm just going to go over what my view models look like, and then afterwards we will get into the actual magic of the application. So you set up the view models. So my first view model actually has add consumption view model. This is when the user actually submits information onto the application and how we get that information from the user interface and then to our web API. So instead of doing the code behind the button and also doing the code onto our actual model or our class, we actually just use a view model where we are able to firstly declare and also create constructors for our properties. For an example, the ID, the consumption, and the date time. And then after that, we do a constructor for our actual view model. So why are we doing this? Because, like I said, you have to send the information from the interface and to the API itself. And then the next thing that you would note here is that if you remember just a few minutes back, I showed you my model, and my model actually has two integers for ID and consumption. But Someleze, when you show us on the screen on the view model, you actually have strings for ID and also consumption and also the date time. Why? It's very important for you to know that whenever the user is submitting the information from your application using a text box, it will be saved as a text. So for you to be able to get that data from the user interface, you have to have constructors and specific fields within your view model be strings. And then when you want to send that data using your actual model, that's when you do the conversion. And I'm pretty sure that you guys know how to convert a string into an integer or also to a date time. So basically, this is how it actually looks like. And then I want you to note the most important parts of this view model. So I created a constructor here for add consumption view model. And this constructor actually has save command is equal to that command, and then it awaits a specific method, which is save data. And you can see on the next part, we actually have that method, which is save data. What does it do? So what happens is when this method runs, it actually checks for this condition where if the ID is empty or if the ID is 0, if that is met or if that condition is met, it will then run another method within our view model, which is called insert part, or in this case, you can say insert consumption in your case. And then you will find that this method that actually does all of the heavy lifting is the one that I wrote at the very bottom of our view model. And what it does, it actually awaits our API manager. So I have a class called API manager, then runs the add method that is already there on the API manager, and then starts to convert firstly the ID into an integer, converts the consumption into an integer, and then converts the date time to date time. And then right after that, what happens is the message center then sends this information to the API and then refreshes all of the data that has done there. Then the next part would then, obviously, when you want to navigate from one screen to another screen, you actually use the shell.current.goToAsync within .NET MAUI, and then you specify the name of that screen, you specify the name of that view, however you actually call it. Right, so what happens is that when this method is called, those 3 lines of code actually run. So this one waits for the API manager to add the information onto the API. Then right after the information is added into that, it goes to the messaging center, and then it goes to the other screen. Right, that's just the basic of what information I have or data or methods that I have within my add consumption view model. I just wanted to show you that so that you don't say when we are doing the heavy lifting actually of our code, heavy lifting part of our code, you say, where did add consumption view model come from, or where did history view model come from? So in this case, history view model is basically just showing the information from our view model. Also, another thing to note is that at the top, I actually declared an I command, which is called save command. So save command is basically when you don't want to use the on-click event of your button on your screen, and then you just use commands within the properties of that control on the screen, and then you specify which command it is. It'll come to this command. Obviously, you saw it at the bottom that says save command, and it awaits all of the other methods that are coming afterwards, right? That's what we have. We have our view models, and you can see even with the history view model follows the same concept, but in this case, it actually loads the data and you create another constructor for the consumption, and obviously you create an observable collection because you want to store all of the information coming from the API onto a specific collection so that you can display it on your view. Right, that's just basically what I just wanted to show you on what I have. I have the view models already set up for me, the history view model, the add consumption view model. And then on the next part, I also have views set up, which is I have the add consumption view. I also have the history view where it will display all of the information. And how this looks like is just basically the formatting of my view in terms of the grid view or grid layouts, and also the table, because obviously the table will be taking in the text that is coming from the user in terms of the ID, in terms of the consumption and the date time. But what I want you guys to actually pay attention to is that if I go to entry cell, the first entry cell for an example for ID, it actually has text is equal to, and then inside of inverted quotes, and curly brackets, it has binding ID. What that binding ID means, it actually binds the data that comes from the user. It binds it back to your view model, back to your xaml.cs file if you set it up there. And how that works is that you want to save the data from the interface and you put it back to your view model, or you put it back onto your API, wherever you want to actually use the binding context within .NET MAUI. Another homework is to find out how to actually do data bindings within .NET MAUI, and then obviously you will start to understand everything that we're doing here. My main focus today is to actually show you how to consume the data that is within an API and also obviously send data to that API. How can we do that? So I'm just gonna collapse that and go to a class that I added called API Manager. Right, this is where we actually want to write all of our code and actually do what we said we want to do. In this case, you have, in this case, I declared and initialized my API address, and I also initialized my authorization key because I need that for my API. If your API does not have an authorization key, you're probably not going to need this part. And then obviously I started to instantiate or initialize, declared my HTTP client because you want to send HTTP requests to your API. Right, let's start with get all and how we can actually add this information back to our API, or how to actually consume this data from our API. Right, the first step is to actually initialize and give value to your client. So you call upon the client that you have at the top, HTTP client, and then you say client is equal to new HTTP client, and then perks of using .NET 6, you're able to have suggestions. And then right after that, obviously when you make requests, you need to add specific headers. So in this case, I will say client.add, I'll say client.default request headers, and then I say .add because I need to have headers within my specific requests so that my API can be able to allow me to read data from it. And then I'll just quickly press tab. It will say accept application JSON. So that will be the content type. And then another part, because my API is actually protected, or you need to log into the API to consume that data, I'll add another header. So default request headers, and then I'll say .add again. In this case, is basically not just going to be the content type and all of those things, but I need to specify the key and the value of my specific API. So in this case, I already have it written up somewhere. So I'll just paste in the name of the key, and then the value. In this case, if you understand what I'm trying to do, what will be the value of my key? Already the value is the authorization key. I don't need to write other specific string text because I already initialized it or declared it within my code at, I think, line 14. So I'll just call it in and say authorization key. And then you'll find it's there, and then I close that. Right, but that doesn't really pull the data from the API itself. So how can you do that? So in this case, I will say var response, in which this is the reason why I like .NET 6 so much. It gives you suggestions of what you want to do. So I'm going to put it in a variable called response, right? Var response, and then I will say await client.get async. But I do not want to actually say get async, but I want to say get string async in this case. Because the reason is because the information that is being returned from the API is actually not just a data that you're able to read out of Visual Studio. So in this case, you want to read it as a string, and then obviously you deserialize the data into a JSON content and be able to put it in a table or whatever that you want to do. So in this case, I say get string async, and then right after that, I can say the URL, or if you want to be very fancy when you are doing your code, you can put it in curly brackets here, which does basically the same thing because you're just using the URL that's already there. And then right after that, what you want to do actually is to just return whatever value that is coming from your response. So this is where you say return, because each and every single method within C# you are able to actually do a return. You need to return a value within that method. So you say return, convert that specific information that is coming from the API to a JSON. So you say JSON convert, JSON.convert. Then after that, what you're gonna do is say dot, and then obviously you say deserialize object. So in this case, I can see that it's not picking up what I wanted to pick up. We need a specific file. So we need a plugin or an extension that we need to actually install. So what I'm gonna do is to right click on this, and then I say quick factorings, and you'll see at the bottom, I don't know if it's visible on the screen, but you'll see at the bottom, if I do the quick refactorings, it says install package new newtonsoft.json. So I'll say find install the latest version, and then what Visual Studio in the background will do to actually install that extension or that plugin that I actually need. You will see it at the top of my code there, you'll see, and then I'm able to use JSON.convert. And then in this case, I say I'll say JSON.serialize, deserialize the object that we want to deserialize. And then obviously I need to put it in a specific schema. So I'm going to say list, and then .NET 6 comes to the rescue again, and then it says deserialize object onto this specific list or onto this specific schema that is coming from our consumption model that I showed you earlier on, and then it will deserialize it onto the response. So it will take the response and then deserialize it and put it into the specific schema that we want it to be using the JSON convert.deserialize object. Right, so basically that's all you need to actually read the data or get all of the data from your API. And then the next part is to actually come to the add part now, where you want to add the information there. So hopefully I can do this quickly enough for you to follow along and not waste a lot of time. The first step for you to be able to do that is you need to have values. So how do you add those values? Those values, in this case, we're actually going to be using the consumption module quite a lot because you need it. So what you're going to do is to actually say consumption. So call up your class that you already created and say consumption1 is equal to new consumption, but that's not what we want to do. We want to actually pass in values onto that class. And then for ID, which is the property that is within the class, we say is equal to ID. So that ID that you see on the screen, the second one, is not an ID coming from the class, but it's the ID that is the parameters for this method. And then the next part is consumption should be consumption, and then daytime should be daytime. Right. That's awesome. That's all you need, because you want to pass in the information from the view onto the view model and obviously onto your actual model, and then send it to your specific API. So what's the next step? The next step is to actually make a request to our API. Which request? We actually want to send a message to our API. So I'm going to say var msg, which will be for message, is equal to new HTTP request message, because I want to send a message there. And then I need to specify a method. So when you send that, obviously when you send information to your API, you need to specify a method on which method you're using. Are you using a post method or using a get method? So in this case, I am just going to say HTTP method dot post, right? And then right after that, what you can do with your code is to actually specify the URL of that specific API that you want to send the HTTP request to. So again, when you try to be fancy, just like me, I'm just going to put this in curly brackets and specify the URL, and then you close off your code just like that. Right. So that's basically how you want to send that method, or you want to send that message to your API. But now That's not all there is to it. You just made an HTTP post request, and that's it. You're not sending anything. How do you send anything? Before you can do that, just like how we were getting information from our API and displaying it on the views, you need to actually use the headers on that API or on that request message so that you can be able to be logged in if you have an authorization key for your API. And what I love again with .NET 6, it actually gives us a suggestion on what we can actually do. So in this case, instead of saying content type, you say accept which kind of content type that you want. And then right after that, again, we need an extra layer of headers again. So message.headers.add, and then what do you want to add? Again, what's going to happen is you need to specify the API key, which is .NET Conf student zone, where we are, and then you specify the value, which is the authorization key. Then right after that, now you have the headers, you've sent the request, and it's just headers. That's all there is to it. But now what you need to do is to actually send all of the information that you are getting from your user. How do you do that? You just say message.content. So you need to specify the content of your message, and you say JSON. JSON content, right? So JSON content at the bottom, and then you say .create that content based off of which schema, the schema that actually comes from our consumption class, again, because that's how it actually mimics our API, the class mimics our API. And then where are the values coming from? The values are the ones that we just implemented earlier on. So you say consumption 1, and then right after that, you close that with a semicolon so that we can run away from errors. And then another part now is to have a response after sending the content to our API. And then you say await client, because client, our HTTP client or our HTTP client that we declared earlier on needs to send this information to our API. So you're going to say client.send async, and then what message are they sending? You are sending the message. So the message has all of this information, the headers, the content, and obviously the authorization key with the value and all of those things. And then the last few parts would be response.ensure success status code. So in this case, when you ensure success status code is that you want to know if your information was sent to your API, and once it was sent into your API, your API will send you a 200 code or status code where you are able to actually know that your information has been sent onto your API, right? And then the last few bits, obviously, you might not really need as much, but you just want to, let's say you want to see the returned JSON. So you can say var returned JSON, and then you say is equal to, in this case, you say await again, and then you say response, right? Because you want to read all of the information from it. So response, and then again, .NET 6 onto the rescue, content.read as string async. Again, what we saw earlier on, it says get string async, but now we just want to read it as a string async. So it's an asynchronous method. And then after that, either you can say, you can use the var return the JSON convert deserialized object, return JSON. It is solely dependent on you. So again, that's all you want. That's how it's gonna happen in terms of sending the information to your API, and then obviously just returning whatever JSON is returned from your API. Right, enough chit chat. I just wanna quickly run this because we probably over time a little bit now. So what we're gonna do now is to actually run it on my Android emulator. I showed you the views, already did something for my views, so I don't want to show you that. I just wanted to be focusing on our specific API manager and how you can actually get data from your API and then send it back. So I'm just going to quickly choose a different emulator, which is my Android emulator. I don't know why. Quite a fan of the Android emulator, and then just quickly debug it. Hopefully, if we have errors on our application, then obviously we'll be able to see what exceptions are there. And then obviously we all know that whenever you do live coding, I think really goes as planned. But while we wait for that, again, just want to stress this to you. As your homework, go find out what MVVM is all about, and then also be able to understand what data bindings are within .NET MAUI, so that you can be able to understand the different levels of data bindings that are already in store for you within .NET MAUI, and then you can be able to utilize them at any given point in time for application or for whichever solution that you're actually building. And another part is that which you will see running the application itself is that you'll be able to see stuff like tabs. How do you add tabs on your views, or how do you add tabs onto, say, for an example, onto the screens that you have of your screen, and then how do you run the load command that will be able to show your application or show all of the information that you're trying to get from that. And again, this session is not the only session that is within the .NET Conference Student Zone. Make sure that you are following along with the other sessions. Again, I'm using an API that Chris actually built. So make sure that you watch that session and you follow that session properly so you can be able to use it if you are following with this session. And this code will be available to you on the GitHub repository that we have for the .NET Conference Student Zone. So you will see all of the machine learning models that were already there, all of the .NET MAUI applications that we built, the IoT solution, and I can see that it's just trying to boot up. So it's booting up our emulator. Hopefully that won't take too long. And then again, this session is actually onto a part where you are able to see, right? So I have this application running here, and it shows you the home page of my application. I have home, I have history, and then I have add. So if I click on history, in this case, takes a few minutes, tries to run the code that we have in the background to actually display all of the information from our API. As you can see, there's a lot of information that Chris has already put into the API, and everyone else that's been using this API, and you can see all of this information, the data that you want to display. And then in a case where you want to add more information or you want to add more water consumption, this is where you click on add new part, and then you can see ID is flashed out or is disabled. It's disabled for a reason. You don't want people to be providing an ID of which water consumption you have, and then you can specify how much you consume. So I'm going to say 156, and then I'm going to add, let's say, today's date, which is the 7th of November, and then I say 2022, and then I say check, and then I try to save the information. Once it saves the information, it takes me back to the history page, because it needs to show me how much of it needs to show me that it has added all of the information that I needed onto the application or onto the API. So what you would need to do if you come to this part, you need to run that refresh button or try to refresh the information that's there. And you will see, if you go to the bottom, it says ID number 13. It added in the information onto your API. Basically, that's just how you add information back to your API. That's how you display it using your .NET MAUI. And obviously, you need an API manager on your application code so that you can be able to pass in the proper information, like your authorization key if you have it, and also all of the headers that you would need, and obviously the schema of your application. Other than that, I hope you guys learned quite a lot. And again, can't stress this enough. Go find out on what MVVM is all about, and also find out about data bindings, because I used quite a lot of them onto this session and this demo, so that you guys can be able to use it and see how you can pull data from the interface, put it onto your model, put it back to your API, and then pull back that information again from your API, put it in your model, then bring it back up onto your interface. So you need to understand what data bindings are within .NET MAUI. Other than that, I hope you learned a lot, and this code is available to you on the GitHub repo again. So build away. From me, thank you so much. Make sure you catch up on the other sessions, and also this session as well, so that you can be able to have a full blast of projects that you can use that are using the very same concept around water consumption. Thank you so much for coming to my session. If you have any questions, you can reach out to me on Twitter, or you can pop them in the chat, and then obviously we'll get to them when you obviously after the sessions that we've had for the .NET conference. Bye, everyone.
Great. Now we have our Maui app. What are we doing next?
Well, we mentioned before that when you create a backend, you can put anything on the front. So we've made a .NET Maui mobile app. Let's make a website with Blazor that sits in front of that. So Justin Yu is going to teach us how to make that front end on our backend that we made earlier.
And that'll be great. This is our second Blazor app of the day. So hopefully you're a little bit warmed up here, but Justin's going to take it to the next level. All right, Justin, take it away.
Hello, everyone. Good morning, good afternoon, or good evening, depending on wherever you are. Throughout this session, I'm going to build a water consumption tracker application using Blazor WebAssembly that talks to a backend API. I'm Justin from Microsoft as a senior cloud advocate. This is my Twitter handle. So if you follow me on Twitter, you can hear a lot of talks about .NET, Azure, Power Platform, and so forth. So this is the agenda for this session. So I'm going to build a Blazor WebAssembly application as a front end. And then I'm going to add as a functions application as a proxy to communicating to the backend API. And finally, I'm going to deploy both applications into Azure Static Web Applications. And these will be done purely on GitHub code space. All right? Are you excited? Yeah, let's get started. So we have less than 30 minutes. So I'm kind of in a hurry. So let's get started. So first of all, I'm going to build the Blazor WebAssembly application. So before that, I'm going to create the empty solution file. Then once it is created, then I'm going to create Blazor WebAssembly using .NET CLI. So once it's added, then I'm going to map that Blazor WebAssembly into the solution file. By doing so, I can work on at the root level. So it's added. So I'm going to .NET restore. I'm going to load the NuGet packages, and it's all there. Then just I'm going to build that application as an empty application. And then once it's done, let's have a look. So we have created water consumption solution file, which is in the source and web app. And also once we're done, we have the web app as a Blazor WebAssembly application. And let's check the settings file here, because sometimes it is the port number is different, because we are opening the port number 5000, 5001, but for the Blazor WebAssembly application, but it's something different. So let's change it to until 7, and then let's change it back to 5001 and 5000. That's it. So we changed it. Then what do we do? And .NET watch run, and we just run this application whether it is working or not on GitHub code space. It sounds like the running here, and then once it's open, and then it says, okay, the port number 5000 is available. So just click the browser, and it will be showing us that this the Blazor WebAssembly application, which is running fine. So which is all good now. So I'm going to stop it for now here. So the purpose of this session is that we are building water consumption tracker. So let's put some the data for the water consumption. So in order to do so, I'm going to open that index.razor file. Index that page, we are going to add here and with some tabular data format. So the first of all, I'm going to add some the C# logics here within this Razor file, something like that. So what it does is that it randomly starts from the January 1st this year, and I'm taking 300 days. So every day we will have the water consumption data as a random manner. So, and it will be stored into this consumption the model. So this is the list of data we are going to use. Then it says we don't have any this water consumption item model class yet. So I'm going to add this the model here. So models, and here I'm going to add a class file called water consumption model. And then so the file is created. So, and I'm adding a few contents here that describing what the water consumption model look like. And within here, water consumption model is basically the wrapper class. And within here are all the collection of water consumption item model called as a property of data. And that data has date value and also consumption value as well. So this is the main the data format. So in here we get the water consumption item model. Then we all good. But it seems to be let's say then we have the data ready, but we don't have the presentation layer yet. So I'm going to add this the HTML piece and piece to render this data. By doing so, so what it does is that the Blazor assembly, while it is loading, first of all, the consumption, the property is empty. And while it's empty, it will be showing the loading. And then once it's filled out, then this tabular data will be appearing. So let's take a look. So I'm going to build this application, but this time I'm pretty sure it will be failing because we have no idea where water consumption item model is. That's why we put here set using models. Then build this again. Then it will be okay, right? So once it's built, then run this application again. Now we have the hard-coded data here. Then we will be able to see this tabular data, right? So starting from the January 1st this year and every day, so for 300 days. Yeah. So we have data ready, and we have that data showing on our screen. But that's not fun because it's the boring tabular data. So I think we can change this tabular data into some more visualized format using chart library. So let's start with let's add some chart data here. So first of all, I'm going to add a NuGet package into this web application using the Apex chart. So there are a bunch of other the chart the package library, but I'm just choosing this because when I search up on Google, then it does the firstly coming up. So I have no idea why is it coming up first, but yeah, I just use it. So, and it has the two parts. One is JavaScript library, and the other one is the Blazor component part. So first of all, I'm going to add Blazor component here. So instead of using table data in here, I'm just using the Apex chart component, which is basically we are using water consumption item model type with the data sources consumptions, and we are using x-axis for the date, and we are using y-axis with the consumption the value, right? So let's check why is it yeah. So we still need to add some sort of using the directive here. So using Apex chart, then I think it's fine. So basically, we are using the same the collection of the water consumption data for the Apex chart and this tabular data. So let's take a look. build this application again. Then should be fine. Then run this application. Then see how it's going. The Blazor web application is ready. So if I refresh it, then oops, it's reload, which means it's an error because as I said, I haven't added the JavaScript bits and pieces yet. So let's add JavaScript bits here in index.html here, and I need to add to the Apex library JavaScript. So copy here. Then once I add it, and can you see that? See, it automatically recompiled the entire application and hot reload. The feature is available, so it's ready. So I don't the recompile, but if I refresh it, then the chart data is coming like that, right? So we have all the chart data, and which is the same data as this tabular, right? So I'm just stopping the coding here, and then I will remove this chart part, table part, so that we only focus on the chart one, right? So we use hard-coded data for this chart to visualize the water consumption rate. But let's make a little bit complex. So instead of using hard-coded data directly on Blazor web application, we simply call the backend API from the Blazor WebAssembly, right? So in order to do so, we need to have the backend API. So we have already a backend API application in here. So this is the one. So we have the backend API using the as a functions. So this is the one, and it has this Swagger UI. So what it does is that we have the API key there, and when I call this consumptions water, then it will be displaying us with this bunch of the data. So basically it's the same. So we are going to use this part. So how can we access to this API? We have OpenAPI document here, and currently it's displaying the version 2. So instead of using version 2, I'm going to use OpenAPI version 3 document. So it uses OpenAPI version 3. So let's just copy and create a new file called openapi.json, openapi.json file, and paste it here. So with this, so we have OpenAPI document ready. Now, what can we do is that using this OpenAPI document, we can create the proxy client using this the generated in .NET. So how can we do it? So we use nswag CLI. So with this nswag CLI command, we can create the proxy client. So what it does is that we read openapi.json file and create, based on that document, create the proxy client.cs file on the web app, right? So it does create it. And here we created proxy client, right? So we are going to use this one. So instead of directly calling the API, we just simply use this proxy client. So dynamic, so we can just use the API call just like the normal HTTP method, right? So we have the proxy client. Now, what we can do here is that in order to do so, I need to create the app settings.json file, because we need to let the application know where this the API application is and how what the API key to for the authentication. So I'm going to create a new file under the www root and called app settings.json, and here I will put here. So this is the API host, right? And this is the API key. And what the first one is that because we are running this application on code spaces. So that's done for the API app settings. Now, and then we need to change. We need to add the proxy client, because we are we are calling that API through the proxy client, but we have no idea. This application has no idea how to call the proxy client. So we need to add, inject those proxy client. So this is the one. So I will add this one. So what it does is that we create HTTP client. We create, then we get all the API host and API key from the app settings and add that API the key to the HTTP header and call, and then create proxy client instance. But in here, you might be wondering why it's not showing like the red line or yellow line or as the alert or something like that, because sometimes the GitHub Codespace language server is sometimes dying. So that's fine. So we can just simply reload Windows, and then actually it closes GitHub Codespace and reopen that again. So we can start now. So yeah, it's reloaded, and then it will show us some sort of indication we need to do something, right? So let's wait a little bit second here. Then it will show us, yeah. So see that here. So we have we need to add some sort of the using directive here. Then yeah, it seems to be fine, and yeah, all good. Now, so we are ready to use proxy client, and then how can we use this proxy client within the index.razor file? So we need to add inject the proxy client at the beginning. Then within this logic, we just simply remove all the hard-coded bits and pieces, and then we just simply change this part like that. So then what it does is that, so proxy client, we have within the proxy client, we have the water consumption get water consumption data async method, which is actually calling the backend API. So that's it. Then I think that's it. And no, not yet, because we are not going to use models any longer, because that proxy client has everything, including the models. And here, and also we need to using web app proxies. Then this the red line will be disappearing, right? So, and here another red line, because the y-axis is expecting decimal value, but actually the proxy client uses a double value. So we need to explicitly convert this one, convert to decimal. Then I think all the things is done. Right. So build this application again. Let's see how it's going. So the application was built successfully. Now, so run this application. Then see how it's going. So application is running fine. Now, if we reload, refresh this page, and that the chart should be fine. That chart is actually, the data of that chart is actually coming from the backend API, which is really good. So we have now directly integrated with the front-end application, which is Blazor assembly, WebAssembly, with the backend API. Now, let's take a look at this. Within here, when we publish or build this application, that www root on all the files under the www root is published as well, which means we are expecting this app settings.json file on the web. Let's take a look. If I say app settings.json, and we will be able to see that. And here is that we are able to see the API key, which is not good, right? So we need to hide this API key from being publicly accessible. Now, how can we do that? in order to avoid this kind of the security concern, then we need to add some sort of proxy API to encapsulate all the API call to the backend API. So let's add as a functions proxy API application for now. So we have all the Blazor WebAssembly. The front-end application is ready. Now we are going to build the proxy API application. So first of all, I'm going to create the function application calling proxy app. Then once it's ready, I'm going to add this proxy API application into the solution. So for now, I'm going to use .NET. I'm going to use C#. In here, then see the proxy application is ready. So I'm going to add this one into the solution file. So once we open the solution file, and it used to have web app, but now we have proxy application. So the proxy application is ready, but actually it's not ready. Now we need to be able to communicate this proxy application with the backend API instead of using the Blazor WebAssembly application. So how can we do that? So we have OpenAPI documents here. So using this, we are going to create another proxy client to the function application. So what it does is that we read OpenAPI.json file and create another proxy client on the proxy application, which is function application. Now, we have proxy client here. So we are ready to consume that proxy client. So how can you do that? We don't have any trigger yet. So go into this proxy application and create a new HTTP trigger to handle those the backend API connection. So I'm going to choose number 2, which is HTTP trigger. Then it says it creates the HTTP trigger. So we are going to use this part. But this is a static class, so I'm going to remove this static the modifier and add this constructor, because we need to inject the proxy client into this the HTTP trigger. So I added this part. Then also I need to change this static method as well using some slight modification into this part. And so it uses exactly the same endpoint like that. So we don't have to worry about, we don't have to, modify the existing Blazor WebAssembly, just except changing the base URL. So let's take a look. And then once it's done, and this part, all the other part is not necessary for us. So we need to change it. So how can we change it? Because we have already logic from web application in index.radar file here. So we are simply calling using this one in here. We simply use this one, but instead of using this proxy, we are using this _proxy. And that's it. And then once it's ready, return new OK object result, and that's it. So how is it done? Really? But we have no idea, because the proxy client we have no, the declare the using directive here, but it doesn't show the red underlines here. So let's refresh this window again. See how it's going. Sometimes the language server is dying a little bit from time to time, as I said before. So you see that the color has changed. So it used to be just the sky blue color, but it now changed into the red green color. And then it will show us like this. So we need to add something like the using directive here, and also we need to add yeah, I think that should be fine. So again, .NET build, and we have so we have all the application built. Now all good. Really good? No, not yet, because we the inject proxy client as a dependency, but we haven't declared, we haven't defined where we need to inject this proxy client. So we need to add the startup file. So where should I put this startup file? In order to do so, we need to add another NuGet package. The function directory in here. So in here, I just add this one. And when we see here, as a functions SDK, the version is kind of old. So we need to update this version with the newest one. So it will be changing into 4.13. So, which is the latest version of as a functions SDK. So now it seems to be ready, but not quite yet, because we haven't let the local settings.json file know about where the API host is, where the API key is. So I'm going to add these two things from here. Just copy this API host and API key. Actually, we don't need this part anymore. So just the copy those values from app settings.json into local settings.json. So here, like that. So I think we're almost ready, but not quite yet. So add another class called startup. Now we have startup file in here. Then for this, because this is as a functions IOC container, so I'm going to use this one, and also I'm going to change this part to use something different. And then it says I need to use a dependency injection, and also if I need to implement this configuration the method. So within this configuration method, which is almost similar to what the program.cs file of Blazor WebAssembly. So I just copy a similar thing, and then just add more the using directive, something like this, and then something like this, and another one. There we go. But in here, we use the configuration. But as a functions doesn't natively add this configuration yet. So I'm going to add another configuration overriding method within this startup file in here. So it actually reads the environment variable, which is app settings value, and then it will be converted into configuration file like this. So basically, it's the same function as what of the program.cs file here. So basically, add HTTP client, create proxy client, and inject it. And in here, as basically create the HTTP client, add this host and API key, and create proxy client, which is basically same. And once it is added into as a dependency, then it will be able to call the proxy client as a dependency within the proxy HTTP trigger. So I think this is done. Okay, let's build .NET build this application. So once the build is ready, now let's start function application, func start. Then it will be showing us the one endpoint here. So when I click this, then it will be show us some sort of the tabular data, because which is called from the proxy API. So I think currently the proxy API is kind of in sleep mode now. So let's take a look. It takes time to get the value. So once it's done, then we are able to use this proxy API. Now let's I think it's almost done, but let's assume that it will be done, right? And it will eventually it will be showing us the one. So but for now, I'm going to use I'm going to stop this application for now. Then I think it's kind of halted for now. So let's assume that as a function set proxy application is ready. So we have the Blazor WebAssembly is ready, and our proxy API is ready, and we have already the backend API is up and running over there. Now, what we need to do is that we need to integrate both the Blazor WebAssembly with the proxy API application. So in order to do so, I need to add some sort of the course settings in local settings.json file here, like that. Now, then, as I said, just make sure I have removed all the API host and API keys from app settings, which belongs to the Blazor WebAssembly. So we don't need those API host and API keys any longer, because those keys are handled within the proxy API application, right? And then once it's done, we probably need to change this program.cs file, which is because we are not using the API host and API key from here anymore. So let's slightly modify that part. So I'm going to update this part. I'm going to update this part like that. So it remove all the things. Instead, we just simply use the same address of the Blazor web application and the as a functions proxy application. Now, also we need to add, if we want to deploy this application into as a static web app, we need to add another file called static web app.config.json file, and in here we need to let the application know we are using .NET version 6. So this is ready. Now what we need to do is that the third part is that we are going to deploy this application, both applications, into the static web apps. So in order to run this file on the local machine, so start from the SWA CLI initialization. So once we run this SWA CLI, okay, not this one, CD. So we are going to go under the repository root and run this SWA init again. Then it will show us the configuration. And actually, the funny thing is that it automatically reads the environment. We are using .NET. We are using the Blazor WebAssembly. We are using the as a function proxy. Everything is there. So we just use the default setting, except the last one, because we are using the port number of 5,000, but it says it's 8,000. But that's fine. We just simply code yes. Then it creates the SWA CLI configuration and simply change it to 5,000. That's it. Okay. So we have built our application. We have integrated everything. Now let's take a look at how we can use the SWA CLI. So we have initialized SWA CLI, and then we are able to see these bits. So now SWA start And we are able to, we are running this both Blazor WebAssembly application and as a function proxy application in our local environment. Now, when we click this this URL, and it shows us with this page, which means the Blazor WebAssembly application and the proxy API is working perfectly fine in our local environment, which is GitHub Codespace. Now, this time we need to deploy this application into Azure. So, excuse me. So I'm going to start here. So what I'm going to do, I have already created the SOA application, SOA instance on Azure. So I'm going to just use this command. Use this one, which means I'm going to use SOA deploy and deployment key to use this one. That deployment key is representing the specific the SOA instance. So use this one, then it will create the artifact for me. Then also it will, deploy this application directly from this GitHub Codespace into the Azure the SOA, the static web app instance. So let's take a look. So it will take some time. So where did I start? So yeah, it's done. So when we click this application, this URL, then it will show us this part, which is really good, but it has an error. It has an error. See this error? This one is because we haven't done this configuration yet, because we know this backend proxy, this proxy API need to know where the backend API is and with what the API key is, but there is no settings here. So we need to add this part. So create add one API host, which is the pointing to backend API. Another one is API key, which is this one. Now, once we are ready, and then save it. Now, once it is saved and we refresh the page, then it should be fine. Okay, it's currently the error. Now we are refreshing this page, and it should be showing something here. Oh, okay. So let's have a wait and see how it's going. Yeah, it's something coming. See, so the chart is coming out. Now we are all good. So we have built the Blazor WebAssembly. We have built the backend proxy, the proxy API. Now we are integrated these two things and deployed both applications into Azure static web apps. Right? Everything is done. So I'm done. So how's this session? Because I kind of talked a little bit faster than I expected, but I'm pretty sure, I'm pretty sure, and you enjoyed this session and this live coding session. But if you really want to run this application on your end, yeah, I have got some homeworks for you to do. So these are all resources. So the first one is the student the resource you are worth having. And the second one is a cloud skills challenge. So visit aka.ms/.net student CSC, and you will be able to see a bunch of learning resources to have a challenge. And the third one is our GitHub the repository for the entire the session speakers. And the fourth one is that specific live coding the repository, because you will be able to see this repository there in aka.ms/Blazor water consumption. And if you are interested in using GitHub Codespace for specifically for .NET developers, then visit this the last URL aka.ms/devcontainers.net. Then you will be able to see the bunch of settings for your GitHub code spaces for specifically for .NET development, right? So thanks for listening. It's Justin.
All right, we just finished our Blazor water consumption tracker website with Justin, and now we're coming up to our next session and our final session.
Yeah, Diego Colombo is going to teach us how to ace our next assignment with .NET. He's got a lot of experience teaching computer science and software engineering, so I'm really excited to see this session.
Me too. I'm ready to learn a lot from this one. All right, Diego.
Hi all, I'm Diego Colombo. I'm a principal software engineer in the .NET Interactive team. And in this session, we're going to cover what's next. It's about getting top marks for your next assignment. What we're going to see here is that we're going to just bring together a few of the things that you've seen in the previous session and see how test-driven and .NET can really help you going through your assignment at school. So, to get the assignment done, the more important thing, I think, is to know, what does it mean to be done? What is done? Done usually means that you are just through with all the assignment, task has been completed, and the thing you built that satisfies the requirement, the specification. So essentially is doing exactly what it's supposed to, no surprises. Doesn't mean it's perfect, but it means no surprises. If you can agree upfront with somebody about what are these expectations, then these are acceptance criteria. So that means that when they are all passing and satisfied, your submission, your work is acceptable. And this is what we usually do in software engineering. So we really try to get these requirements, what these things is supposed to do, defined up front. So let's think about it. Like, what does it mean if this is an assignment that you do at school? Well, that means that probably you're ticking all the boxes that whoever created the assignment for you is expecting to. So that means that should be accepted. This approach is called test-driven development, or is TDD, the short for you friends. There is one thing here though. You could test something you already done. So that means you are validating your assumption. Doesn't really mean though that you are satisfying what they asked you to build. TDD is development or test-driven design, is where the test is driving your whole implementation. The thing you are creating, the design, how it works, how it behaves, the name of the function, the name of the classes, will be driven by the test, how they're supposed to work. So this is really where we're going to do this upfront. We're going to just talk and see with your teacher what's the point, what things should be done, how they should work. You can read more, and you're going to have more information that I pointed in this slide, also the call to action at the end. Let's understand, why do we test? There is a lot of reason why you should be testing. There is a lot of reason why in the industry you should do tests. And there's also a lot of different meaning to test, depending on when you do them. If you do them up front, if you're testing just classes, it's a unit test. It's a very small test that looks at that small, well-defined behavior. The other tests where you're testing an end-to-end, like you click on a button on a UI and you're expecting something else to happen because also some services in the backend are hit. That's an end-to-end. Or is also a user experience test. You are satisfying an expectation from the point of view of a user as opposed to a design requirement of your class, service, whatever that is. Why do we do that? Well, knowing that you're testing, you do it because you want to make sure you're building the right thing. Like, you're doing the assignment, you think you know what you're supposed to do, and I think you want to do that. So the tests are helping you understanding the fact that you are still on track. You're doing the right thing, and you're marching towards the solution. Also, you want to know that he behaves correctly. So everything upfront you discuss with the teacher, or is part of the requirement, or is in the notes, or you had additional question, or however you gathered that knowledge, you know that this thing you're building, he's doing and behaving the way he's supposed to. If these two are met, we were talking about acceptance criteria. That means if you are submitting this assignment, that should be approved, and hopefully top marks. But also, this is giving you another thing which is quite important. As you go through, you don't need, as we said before, you don't need to create the perfect solution from the get-go. Software design is a discovery process, is an iteration, is a loop, is a continuous loop that you want to improve. But how do you change things, being sure that whatever changes you're doing are not breaking what it was supposed to do before? Well, that's what the testing are doing. You do it because you want to be able to improve, change, and do all those beautiful things without breaking anything. And that's important. So, TDD is essentially a cycle that until everything is green, you keep on going. But every time you do this, you're going to discover more. The API is going to expand. You're going to find additional behavior. So at this point, you build a test. You don't have yet functions and all the things. And so you start introducing them. So you keep testing and refactoring, modifying, and discovering new designs. And guess what? Visual Studio and .NET, they really work very well together and makes all of this way easy, or a lot easier than it could be in other places. That's because C# compiler, which is Roslyn, is fully integrated with Visual Studio, and it's not just a compiler. It just doesn't make your source code into executable code. It does a lot more. It's able to analyze your code. And we use that to give out things that help you refactoring code. They help you understanding good best practices that get are coded and that will help you going through. So you're going to see in Visual Studio a lot of light bulbs, quick fixes, wiggles, suggestion. You just follow them and they help you design better class. Something is supposed to be read-only. This could be private. This is not used. That could be deleted. This could be made static. So all those things is done. And it's not just editing text. As you touch anything through refactoring, the whole system looks at that. And that means if you change the name of a method or a class through refactoring, every places where that thing is consumed gets updated for you. It compiles, and happy days. As you write tests, somebody has to run them. So far, usually you would have CLI or command line interfaces to execute a test and see how they go, green, red, whatever. But there is a nice feature in Visual Studio, which is called live unit testing. What this thing does is it keep on looking at any changes you do, and underneath the hood, will continuously compile and run the test. As we do this, you get feedback immediately about what you're doing, what is missing, if it's passing or not. And as you touch code, you're going to see green and red come and going. And this is what's going to help you focus. Once you pin down your requirements, you go off and you start writing code and you focus on your deliverable. Now, we're going to use all of this to make sure that our assignment is going to pass, 100% guarantee. So we keep talking about the top marks, but remember that Microsoft is not liable and doesn't guarantee for the top marks. You need to put some of the good work in there, right? So let's go over to the demo. So we're going to implement what we just said. We're going to start with the moving average. So we knew that from the assignment, we need to be able to create a moving average with a window. We should only produce value when the window is complete. As we push data, the average will be produced. And also, we need to understand that it needs to be built in a correct way. So it says that must be created with a positive and non-zero window. So there would be two types of tests, or we can change and transform fact, which is just a single test, into what is called a theory. So a theory is going to use these two values, so 0 and -1 shouldn't be at all a valid window. And then even this one, we want to try different arrays. So we're going to have this amount of data pushed in. This is going to be how big is our sliding window, and this is going to be the expected average. We know by definition how the moving average should work. And also, let's fix this one too. So we want to make sure that we don't produce any value if we don't have enough to cover this. Let's start with this one. So the way we do that is that we want to make sure that when we create something with an invalid window, we should throw an exception where the argument is out of range. Now, here I'm having this constructor. As you can see here, I don't have it. There's nothing to do that. So by using refactoring, I can see my preview and adding not only the constructor parameters, but also we're going to add the private field to store it. So I'm happy with this. It's compiling, but still it's not passing. It's supposed to throw an exception. So let's use that if our windows is less than 0, we want to throw exception. As you can see, I just fulfill the first goal. So this is all good. Let's do this one first now. So how do we test that? So what we're going to do is that we're going to build moving average. We want to have a window that is just one sample bigger than this. We want to push sample. I like this, but I actually want that method to have a different name. So I'm gonna do, we're gonna push sample. We don't have it, compiler error, that's expected. And also we want to make sure that if I don't have enough values, this should bring out that there is no values. We initialize the moving average. So let's do one thing first. We're gonna ask to create this method, push sample, happy days. What we're gonna do is that we're gonna store that somewhere. So let's put a queue, for example. So that's some storage to put things on. Instead of throwing, let's just put our samples in the queue. And then let's also update our average. And we have a way to do the through link. So now all the content of that is going to be used for doing the job. And let's look at the live unit testing. It's still broken. What's the problem? Oh, it's actually computing that. That's because we're not fulfilling the design, that I didn't have enough values. And this is tossing that out. So let's be more complete, and then also let's fulfill this other scenario. And this is important. Now look at what we need to do. If I got a moving window, a sliding window of 2 samples, when I'm having this big collection of values, what I'm expecting to have is that at the end, the last 2 values to be used is going to be 1 and 4. So the average should be 5 in that window. Let's look at our live unit testing that keeps on running. It's not going to be happy because at this point, one of the test cases is broken. It's telling you 2 instead of 2 or 5. And look at, it's also giving us an information about delta. So this is the fluent assertion API that we're using that gives a very interesting and easy to read message to understand why it's not working. And the why it's not working is that being moving average, first of all, we should only compute if we've got enough values. These should fix some of the tests, but not all of them. Because also, at this point, we need to make sure that, again, this one is not going to be fixed, because if we have reached the full size, we need to then start also removing things from the sample. So we're going to dequeue. And now we should at least get the first part working. Why is this not working? Let's look at the result. Oh, 0. Oh my gosh. That's it. So if we want to make sure that that thing is not initialized, so when we start, we're going to initialize average with double $none. So that's the expectation. As you can see, as I was typing, was looking at my test, and also by using theory, I've been able to show all these different test cases I've been going through. Then I can even add something like this. Let's test a window of 3. But this new test case should be the average of 2 plus 1 plus 4, which is 7, which divided by 3 is not too good. So let's do this guy like this. And what's the mistake here? 2, 1, 7 again. 3. And we just did. So we filled the whole purpose. Now, this one is interesting because you've seen that I was using also refactoring to change the shape of the class. That's because we are testing this straight against APIs like method, properties, and constructors. Now, this is interesting, but also, it said, of course, it could be read-only. That's adding even more value, because that means that this window size can only be changed at constructor time and not anywhere else. If I were to, by mistake, touch it here, that would create a problem. Also, here suggests me, with new C#, you don't need to specify the type twice. So this is all refactoring. Everything I've done is not breaking anything. And also notice I haven't saved yet. Now let's save this. This is good. There is another interesting story, though. We're going to look at the resume API. Now, this time, it's slightly different. We are testing against a service. So at this point, we're not really calling a method per se, but we're going to be interacting with that using endpoints. So remember that from the README files in the project, what are the requirements here? We want our service to have a Swagger endpoint. The Swagger endpoint needs to be serving an actual UI element. It needs to be HTML served out with a specific element that we're looking for. We're going to look for a div that the ID is going to be Swagger UI. That's going to tell us that that's fulfilled. We want to be able to query resume, so we need to be able to reach as a get a resume endpoint. We also want to be able to retrieve all the resume that are in the database, and there should be more than one. And also, I would like to be able to query by user and just get the resume. So I need to be able to use a query string parameter. Now, let's look on the left is our minimum API ASP.NET Core Web API app, and a few things are missing. So let's start implementing this part. So you are able to use components, and at this point, you see here that we have a Swagger generator, but we don't expose the Swagger endpoint. So let's see what happens if we start adding the application Swagger. So let's see our test. Still nothing. So let's actually tell it to expose a Swagger UI. And the first two tests are okay. The part here is interesting is that I'm actually parsing back the result, and I'm making sure that using a DOM parser that I can find that element with a CSS selector query. Let's look at this one. We want to have a resume endpoint. Okay. So I'm gonna add resume endpoint. We're gonna have this function and whatever. I don't need to redo anything clever. Let's say I just bluntly give back a list of resume objects. That's enough. Let's see how it goes. I can reach the endpoint, but I don't get anything back. I have populated my entity framework model with data, and I can see by these ticks that that code is executed. So I should have these elements in any memory database that I can use for testing, but yet this is not working. But that's not working for the simple reason that I'm not giving back all the resume with information. At this point, let's change our get resume to use resume database. And let's see what it does. And another one is fulfill. I need to be able to reach resume, get the resume back. I'm going to have a list of resumes, and this should be greater than 1. Still, this one is not working. And let's see what we can do. So on this handle, we want to be able to use a query string. This is pretty easy to be done, because if we add an optional parameter called by user, ASP.NET is going to map that value for us. It's going to be able to show us the value by deserializing what is passed in there. Now, the other thing is, though, is that this query is not enough. So let's do something where we need to be able to filter. And let's see. Now, there's only one test failing. Oh, what is that? Oh, look at this. One of the test cases, I want to make sure that my query is case insensitive. This part here is okay, but this one is not. So this check is a case sensitive check. So when I'm passing this one, I won't be able to have that. So at this point, if I want to ensure that that case is satisfied, I want to use something similar. So I want to do case insensitive check, my true values, and now I should be able to see all the resumes. Yay. So we just fulfilled the contract for our assignment. So we built a service. We are testing endpoints, making sure that our HTTP is all wired up correctly, that we expose additional feature as a Swagger UI. And it is indeed a Swagger UI. It's not just that it's returning an OK state, because that's what we did before. If you remember, with the empty part, we were able to hit resume, but we're not able to get any data, and even less filter data. So now the contract that the assignment was giving us has been fulfilled. Now everything that I can do in here will ensure that any change that I do is perfectly safe. And that means that any refactoring that I might want to do, if we go back to our moving average, for example, we could change a few things in here and nothing would be a problem. For example, I don't know, the queue, or we can change implementation. If now I change the throw new, we can even be a little bit more strict. We want to have a message here and tell that's the reason. And now look at this one. No argument exception. And here, just giving the name. Want to be more informed, we can build a more sophisticated function. I'm going to have name. As you can see, this part is still working. And then our test is so good. So we've got our contract. The assignment is done. And at this point, I don't know, is that clever? Is that top marks? I don't know, but this is fulfilling everything. And by using this, we are proving to whoever asked us to do this job that we understood the intent, or if we didn't, then we can always add new test cases, new scenario, and then go back and expand the implementation. And this is pretty much all that there is to TDD and how quickly you could leverage .NET Framework, XUnit, and Loot to quickly iterate on your project and then implement things by being driven by the actual requirement. This is pretty much all that we got for this session, and we got few resources that are quite interesting. So you can find all this code published in the repo for the Student Zone. And also I publish here the link to a very useful piece of information, Introduction to Testing, which is really covering a lot more than what I just did. It's going to tell you about a lot about the very interesting type and reason for testing, as what I introduced, but that goes very in deep on all those scenarios. And thank you so much for joining. I hope you enjoyed all the sessions so far. And .NET, everything you can.
All right, big thank you to Diego and all of our speakers. That is the end of the .NET Conf Student Zone. But don't worry, we have a couple of resources for you to take away. So you've seen this slide a couple of times today, but I'd love for you to all get your Azure subscriptions. It's totally free for students. Sign up for our Cloud Skills Challenge to learn a bit more about .NET and potentially win some swag. Please remember to check out our GitHub repo. All of the content that you saw today is going to live in that repo. So if you ever need to check back with the solution code or anything else, please head to that. And finally, we have a bunch of great C# and .NET learning resources for you. And I know Scott has a bunch more resources he'd like to point out.
Yeah, I'll go ahead and share my screen and remind you that if you've made it this far through the Student Zone, tomorrow and the next day, we're going to have .NET Conf. We're going to be talking about those things November 8th through the 10th. If this is the past, if it's the future, you can go and find the resources that we did have at .NET Conf if you're watching us in the future somehow. Bunch of great content. There's a ton of sessions, community sessions, learning, huge agenda. Check that out. And I also want to encourage folks to go to the .NET website, click on community, and take a look at all the great resources we've got. We are active on TikTok and Twitter and LinkedIn and Facebook, but even better, there are resources near you, meetups and user groups, so you can meet in person or you can meet virtually. And no matter where you meet, we want you to feel welcome in the .NET community. And I also want to call your attention to this button up here that says Live TV. If that button is flashing red, there's a .NET person who is broadcasting live and excited to meet you and talk with you about your journey into .NET. So yeah, this is a pretty cool pre-day for .NET Conf 2022, isn't it, Katie?
Yeah, definitely. And we hope you enjoyed building your profiles and continue to make those your own and build more with .NET. But I think that's a wrap for us, Scott.
It is a wrap. I'm going to go and study all these resources and get ready for .NET Conf tomorrow.
Me too. All right. Thanks, everyone. Goodbye.